Officially, good morning to everybody. Thank you very much for being in Athens with us. I hope you will enjoy the final meeting of our 4-year-long project. And you will also enjoy the location. We have excellent view of the sea outside, and the weather at the moment is on our side. It is very good weather. And I hope we will also have a very productive meeting. Before starting, I would like to thank both our project officer, who is connected online, and Helena, our external expert. You all know her from our previous review meeting at Brno. Helena has been following the project from the very beginning, and I think she has a very deep understanding, nearly as good as we do after 4 years of work. And officially, I would like to ask the representative of the municipality of Varivula Vouliagmeni, Mr. Vangelis Dimitriou, to come and welcome us on behalf of the municipality. The municipality has been one of our key partners, one of the demo site owners, and has been supporting the project from the beginning with dissemination events, promoting the project, and also is organizing the current meeting and the open event tomorrow. So, Vangelis, would you like to say a couple of words on behalf of the municipality and the mayor?
Good morning. My name is Vangelis Dimitriou, and I would like to give a very warm welcome to all of you, especially to the ones that came from abroad. I would like to tell you that our mayor, he was not able to be here today. So on behalf of the mayor, of our municipality, and of all the Greek partners, I would like to welcome you and thank you for being here with us to go on with our meeting. I think we had, as it will go on, a wonderful passion meeting, I would say, and we are satisfied with the results that we have so far, and they will be announced later on to our real site demo. And we will be here for the next 2 days, and you're welcome just to be in touch. I will be in touch with me for anything you might need. Thank you so much again. Our best wishes to go on with our meeting. Thank you.
Can you see me now?
Yes.
Okay. I hear some echo, but okay. Just to say a few words, guys, from my side. So first of all, to introduce myself. So I'm Traian Braza. I'm the project officer in charge of this project. So basically, I took over this project during the last months of the project. So basically, it's my first meeting with you and the last meeting with you because it's the final meeting of the project. So I'm looking forward to knowing you. I'm very pleased to be here with you. I hope you will have a wonderful meeting today. Unfortunately, I'm not able to be with you physically because we have a very busy days at the commission the last at the end of the year. So but you are in good hands with Helena. She knows very well the project from the beginning. She monitored it. She discussed with you for in every review meeting. So basically, she will be leading the technical discussion during the meeting. As I have other meetings in parallel, so I will be disconnected from time to time, but I will be with you at the beginning and also at the end to wrap up the meeting and to answer to you any question you may have for the finalization, the payment after the end of the project. Okay? Can you hear me? Maria?
Yes, we heard you very well.
Okay, I give the floor back to you. Okay, thank you very much. Okay.
I hope you can see us.
Yes. I see the screen and it's perfect.
Okay.
Finally. So once again, good morning, everyone. I'm Petra Colantonio, representing company Phoenix TNT. We were responsible in this project for dissemination and communication, exploitation, and IPR management.
Good morning, everyone. My name is Anata Jakova, also from Phoenix, and I've been in charge in Work Package 9, dissemination, communication, and exploitation as well.
Good morning, my name is Daniel Philippen from Switzerland, SPF, University of Applied Science Ost. Me and my colleagues from SPF we brought in the idea of the external wall heating, so the connex wall, and we're participating a lot now in the last WP7.
My name is Jan Celak and I'm coming from the Czech Technical University in Prague, and we were responsible in the project for the demo in Czech Republic as well as partially for demo in Terrassa in Spain in terms of the air handling unit development.
Hello everybody, my name is Andrea Klinge. I'm representing ZRS Architects, a Berlin-based practice in architecture and engineering, and we were responsible with a team of ZRS for 2 virtual demonstrators and the implementation of the plural solutions.
Hello, good morning. My name is Jaume, and I'm architect. I'm come from Denbelos Comfort. We have developed and we are the manufacturers. We have been leading the wall packages, and that's all. Thank you.
Hello, good morning. Can you hear me? Yes. I am Letiane Beninka. I am an architect from Peak Architects. I am replacing Susanna Proskachova as the manager in the beginning of the project. We are leaders of the Work Package 7 and also the task implementation in Terrassa as architects, and helping Jaume with the system. And that's all, I think. Thank you.
Hello, good morning, everybody. I'm Marta Rufi. I'm representing Housing Agency of Catalonia. We are the agency of Catalan government who owned the demo building in Terrassa. And that's all. Thank you.
Okay, hello everyone. I'm from ETEC, also Catalonia. I'm here instead of Diana. We are involved in Work Package 8, and I was more involved in the LCA calculations and the standardization of the Work Package 8. Thank you.
Good morning to everyone. I am Tony Calabrese from SPF, Institute for Solar Energy. together with my colleagues Daniel Philippen and Alexander Schmidt. And we were mainly involved on the work package 7, so in the development, implementation, simulation of the Connex wall system in the demo building of Cassava.
Good morning, my name is Alexander Schmidt, also from SPF, the university in Eastern Switzerland. And as Tony just mentioned, we were working on work package 7, and I was mainly working on the design of the Connex wall.
Good morning. I'm Panagiotis Rigopoulos from NTUA team. I helped with work package 1 and 4 and task 4.3.
Good morning. My name is Anna Bogacz. I'm here with Gabriela Komorowska and Giovanni Casera, representing BGTech. Within the project, we are mostly involved in the work package 4, 6, and 7. Responsible for development of the window models for prototypes and demo buildings.
Good morning, I'm Jordi Pascual from IREC, and we are leading the work package regarding to the all the parts of the control system, smart control system implemented in the buildings, but also leading the parts regarding to the monitoring. And the EP person from IREC, and I'm here with two of my colleagues.
Hello, I am Jordi Macià, also from IREC, together with Jordi and Angelos.
Hello, Angelos Milonas, also from IREC, whatever it was said before by Jordis.
Hello, good morning everyone. I'm Manos Katsigiannis. We are together with Petros Gerogiannis and Aris Manolitsis and Yannis Atsonios in front, and Panos. The NTUA team, we're responsible for the simulations, the energy simulations, and a part of the monitoring process for work package 1 and work package 7. And have a good day all.
Hello, my name is Yannis Christou from net company Intrasoft, and we were responsible for work package 5, the development of the Lysis and Modest platforms.
Hello, good morning. I'm Marios Logothetis, and I'm also part of net company Intrasoft team.
Hello everyone, welcome to Greece. My name is Dimitris Apostolopoulos. I'm a member of the project team from the municipality of Varivula Viagmeni, which is the owner of the demo building.
Yes, good morning again. My name is Vangelis Dimitriou. I am an electrical engineer. I am in charge for the city planning, the urban planning of the municipality. And just like with Dimitris, we are the team for the municipality of Varivula Viagmeni, the municipality that provides the real demo site for our program, for the integration actually of our program. Thank you.
Hello, I'm Konstantinos Tsoutis from AMS team. Just beside me is Elena Pouliou, Sofia Papadopoulou and Panagiotis Roumeliotis. We are responsible for the smart wall system and the Vula demo site.
Hello, I'm Yannis Atsonios from National Technical University of Athens. I am the Work Package 1 leader and responsible for the optimization of smart wall, and we support the monitoring system at the Greek demo case.
Okay. So this completed the introduction of all the partners. Now we go into the actual technical part of the meeting. The first presentation will be done by myself, and I will try to summarize the characteristics of the project as well as the achievements during the 4 years duration. Just give me 1 second to open the presentation. I hope you can see it everywhere. So we are here in Athens to complete the 4-year-long effort that we made all together to develop new, what we call plug-and-use facade kits. The meeting is organized by the municipality, as you know, with the support of IMS and NTUA. And that it's a first hint of the very good collaboration that we all had during the course of this project. So, who we are. It's an H2020 project. We are 18 partners from 7 European countries. You already heard that the consortium is highly multidisciplinary. For each country that we had a real demo site, we had experts that relate to architecture, manufacturing, the building owners, promotion, dissemination partners. And as you already heard, our 3 demo sites have been one in Greece, the one that we are going to visit tomorrow. The second is in the area of Zlin in the Czech Republic, in the village of Kasava. Unfortunately, the mayor has not been able to travel with us today, but they have been really collaborative during the project. And the third demonstration is in Catalonia, in Barcelona, and the Agencia de Habitat Catalonia is here with us to present also the results that we achieved in Terrassa. 48 months duration. We are now at the last review meeting. The project officially ended in September, at the end of September. What were the key objectives? The project has been approved under a call that required to develop prefabricated facade systems that can combine passive with active elements so that without intervening with the existing facade of a building, to be able to reach the NZEB status of the building after renovation. So the targets were near zero energy consumption of the building, the renovation has to be cost effective, has to be fast, of course environmentally friendlier, and the systems to be developed had to be adaptable and flexible. In the frame of the project, we developed 3 core systems with several variants for each of them. We call them Smart Wall, Connex Wall, and Envelopes Comfort. The Smart Wall was the major development, was mainly developed by AMS. The Connex Wall was the combined development of SPF and CVUT, and Envelopes Comfort was the major development of the envelopes. The Smart Wall has been demonstrated at the Greek demo site, the Connex Wall at the Czech demo site, and of course the Envelopes Comfort at the Terrassa demo site in Spain. In addition to this, as part of the project, we had several other key developments that included a digital platform that was under the guidance of net company Intrasoft at that time, control systems, sensors, and monitoring systems that have been all joined together to be able to give us the end results in terms of energy performance of the 3 key demo sites that have been demonstrated. In total, we had 6 demo sites, 3 real, the ones I mentioned before, and 3 virtual, which were used as replicators to prove that in other climatic conditions we can reach the NZEB status when we implement the key technologies, the plural systems, the Smart Wall, the Connex Wall, and the Envelopes Comfort when they are used in different building typologies and climatic conditions. We used, in terms of the control systems, a user-centric approach that implements control methods that take into account the user needs, and the buildings have been digitized, the real demos and the virtual demos, using a BIM approach, and that has been integrated in the data handling platform, which we call LYSIS. That also includes a decision support tool that we call Modest. The manufacturing of the PNU kits, we call them PNU kits, it's a paraphrase of the word plug and play, which is commonly used for off-site prefabricated industrialized systems. We call them plug and use because they take into account, as I mentioned, the user needs and requirements. So in the manufacturing procedure of all three PNU kits, we had very strict rules that have been followed based on lean manufacturing principles and factory quality procedures. In addition, we developed a number of training tools that will be presented today. And last but not least, we developed and implemented a number of tools that confirm the environmental improvement of the buildings that we will achieve when the PNU kits are implemented, life cycle costing, and also the social acceptance in terms of a life cycle approach and recommendations for the LCA standard. This is a slide to convince you that we have been very successful in what we did. On the top, you see the Terrassa demo site as it was before and as it looks now after the renovation, with a very aesthetically pleasing outcome. The building in the Czech Republic at Kasava, you can see it as it was before and as it looks now. Major change also in terms of the aesthetics and the architectural systems. And the third one on the bottom is the Greek one, which due to the fact that it is a building that it is not allowed to change significantly the facade, the systems not only have been able to reach the NZEP status, but did not alter the facade of the building. The three additional replication sites, the virtual demo sites as we call them, have been one in Bern in Switzerland, where we have an alpine climate and the convex wall has been virtually demonstrated. One in Berlin, a building that has been already renovated and it had a very good energy performance standard when we started the project. So we use this as a baseline for proving that we can achieve the same and even better performance when we install the smart wall. And the convex wall has also been replicated in a group of buildings in Sweden, in Väsby, which is a boreal climate. So we achieved through the project the demonstration of the three core technologies in 6 different climatic zones. The project has been developing in different phases. During the first phase, we had the requirements definition, the preliminary design of the PNU kits, the testing and the development of all the digital and control tools. The second phase actually concerned the manufacturing, and the last phase, which is actually under review today, is the validation of the developments under real and virtual conditions. And this is what we achieved during the last year of the project, between month 37 and 48. The project has been structured around 10 work packages. As you can see from the Gantt chart here, most of the work packages have been completed during the previous periods. during the last period only the work package 7 that deals with the renovation procedures, the monitoring, the technical assessment has been actually active, together with horizontal work packages 8, 9, and 10 that deal with the market and business-oriented strategies, the dissemination, communication, and of course the project coordination and management. Due to delays that we will analyze during the meeting today, we have not been able to complete the renovation of the demo sites at the end of month 36, at the end of the third year. This has been achieved for 1 out of the 3 demo sites. The other 2 demo sites faced some complications in terms of technical development, licensing, and several other factors that delayed the actual renovation. And for this reason, all the tasks of work package 7 have been extended up to the end of the project, including the monitoring, and the manufacturing of the envelopes comfort has been achieved during this current review period. Let's go through each of the work packages that have been active during the last year of the project, which is, as I said, the current review period. The work package 1 has been the umbrella work package that developed and created all the boundary conditions that enable the uptake, the construction and market uptake of the technological development. So during the last year, a go-to-market strategy has been developed and established. The exploitation plan of the plural solutions has been continuously updated and revised in the frame of work package 8. The preliminary analysis of the value chains in the context of a strategic innovation has been achieved under work package 1, the analysis of business models, and the review of the certification strategies. All these have been used to feed the work of work package 8 that we will see later on. The work package 6, as I mentioned, was supposed to be completed, but during the current period, we had the detailing of the final PNU plural kits. We analyzed challenges in the current manufacturing, assembly, and installation processes, although, as I said, the manufacturing of both the connex wall and the smart wall have been completed until month 36, 37. The production methods have been evaluated. We established steps towards future industrialization and identified future cutting-edge technologies that can be feasible and promising for the industrialization, the mass production and mass industrialization of this type of prefabricated facade systems. The results of work package 6 have been presented in the resubmission of deliverable 6.5 that was preliminary submitted during review period 2, but then it was revised and resubmitted during the current period. Work package 7, as I mentioned from the beginning, is the key work package that controls all the activities that relate to the renovation of the demo sites, the monitoring of the demo sites after the completion of the renovation, as well as before the renovation, makes all the assessment in terms of energy, environmental comfort data, delivers the data to the LYSIS modest platform to be able to evaluate the results from the monitoring procedure, deals with the post-renovation building certification, develops user engagement activities, and delivers the techno-economic assessment of the developed solutions. Work Package 8 is the core work package that dealt with the environmental, economic, and social impact of the project. During the current period, we have completed the LCA, LCC, and social LCA analysis. We developed a roadmap for the certification of non-standardized products, or as the PNU kits of the plural project, which, as I mentioned, combine passive with active elements in their manufacturing in order to be able to reach NZEB status. The assessment of both technical, environmental, and social aspects has been completed under the Work Package 8. The market potentials, the business models, and the refinement of the exploitation and innovation roadmap have been undertaken under Work Package 8. Work Package 9 is the dissemination and communication work package. You will hear under the work package presentation that the project has been really active in terms of promoting the results to key stakeholders in the construction sector. In order to achieve this, we developed an e-platform where we have publicly available all the handbooks and the training material that have been developed during the course of the project. And on the right side, you can see the target KPIs that we have set in the beginning of the project, and you can clearly see that most of them, nearly all of them, have been very well achieved with very small deviations in the ones that have not really been achieved. Overall achievements independent of the work structure of the project. We developed 3 prefabricated, off-site prefabricated facade components that can find application in different climatic zones for different types of residential buildings constructed under different conditions and different technologies. And we have managed to reach, through these prefabrication procedures, very good results in terms of the energy and thermal performance of the PNU kits. We have established quantitative indicators to characterize the technical, environmental, and economic developments of the project. That was done even from the beginning of the project. There are several deliverables under Work Package 1 that define these key performance indicators, and the achieved results are reported under Work Package 7. So the summary of the key performance indicators that we have established are, of course, as one would expect, the energy consumption of the buildings that have been renovated with PNU kits. We had set a target value in the beginning of the project, and we can see that this target value has been more or less achieved in all the PNU kits. And the primary energy consumption of the buildings that have been renovated with the PNU kits has been reduced to a level to make the buildings net zero energy buildings. The renewable energy ratio of the building, of course, before the renovation, there was no renewable energy at the buildings. You can see here that the 3 different technologies have a good percentage of renewable energies as part of their design concept, and the connex wall, which is demonstrated in the Czech Republic, has a very high renewable energy ratio to cover the specific requirements, the specific climatic requirements. In terms of environmental impact, all 3 PNU kits have managed to achieve a much better CO2 performance, CO2 equivalent performance than the target value that was established in the beginning of the project. The materials that have been used for the manufacturing of the PNU kits are recyclable to a large extent. The recycling capacity of all 3 kits is at a very good level, and all 3 of them can be 100% disassembled after their end of life. We also address, in terms of addressing the flexibility and adaptability of the PNU kits, we developed several variants. In terms of the smart wall, we have developed 8 core variants. The level of comfort has been developed in 3 core variants, and the connex wall also in 3 core variants. The LCA analysis has been done for a total number of 100 different configurations of the PNU kits. We achieved, despite the fact that the PNU kits have been at their prototype stage, we have managed to achieve very good renovation times. For all 3 demo sites, the renovation time was between 3 and 4 months, taking into consideration all the technical bottlenecks, the delays, in some cases due to weather conditions, the unexpected situations that were faced in the demonstration buildings. This will be analyzed as part of the work package 7 presentations. In terms of industrialization, the target was to be able to achieve manufacturing installation costs that are compatible to the current on-site prefabricated solution. And as you can see from this slide, we managed to have costs that are really competitive to the current technologies, despite the fact that these are hybrid prefabricated facades that have to, in their design and manufacturing, include all the aspects of the technical systems, whether these are PVs, piping, fan coils, organic PVs, the control system, the fire suppression system, and a lot of other technical systems. Nevertheless, if we go to an industrialized production, industrialized mass production of these systems, we are expecting to have at least 6% further reduction due to material and labor savings, a further 20% reduction from the improved productivity of all-in-one components, and 5% when we go to large-scale projects. This can be achieved only if we have mass production under very well-controlled conditions and overcome a number of bottlenecks. In the frame of the project, we have performed an exercise trying to estimate what are the cost savings between the on-site prefabrication fabrication and the off-site prefabrication. You can see here the comparative assessment for all 3 PNU kits, taking into account that our kits cannot be in reality on-site fabricated because you have to introduce in the design and the manufacturing all the technical systems. So this is an exercise just to show how much we can expect to have as cost savings when we compare the current practices with the industrialized approach, prefabricated approach. In terms of key exploitable results, they have been defined even from the beginning of the project. The project delivers 14 exploitable results that cover not only the PNU kits, but also components that are integrated in the PNU kits, like the air handling unit with heat and cooling features, the energy harvesting windows, the control systems, nano coatings, 3D printing, the digital platform, the LYSIS platform, the SEM-based approach for the control systems, sensors. So the innovative developments of the project go very well beyond the actual production of these 3 core PNU kits. What have we learned out of this project? If you ask each of the partner, you will have a different answer, because we have to admit that it has been a very difficult, hard to follow process with a lot of bottlenecks, hurdles, technical, communication, outside our control, like the COVID period when we started the project, it was under the COVID, and for 18 months we were not able to meet each other. However, I believe that we learned a lot of things out of this project. For my understanding, the first thing that we learned that we can achieve really net zero energy operation of residential buildings after facade renovation with this type of prefabricated hybrid systems. We have demonstrated through our processes that it is possible to prefabricate, manufacture, assemble off-site, and demonstrate renewable energy sources integrated in this type of plug-and-play facade kits, achieving considerable savings in terms of time and costs. We have proven also that it is possible to integrate in the production of these types of kits a number of different technical features that are either related to thermal or electrical storage, to control, to fire safety, sound improvement. So we have shown that we have a flexible solution for residential building retrofitting. Even we could include an EV charging socket outlet in the prefabrication if it is required in the near future. However, nothing is perfect in our world. There are a lot of issues that still need to be investigated if we want to reach a mass production under industrialized conditions. Bottlenecks, experiences are, first of all, the design has to be always adapted to the building characteristics. The wall integrated heating system has to be done under very well controlled conditions. We need to have what I call a performance-based building design for the renovation, namely to design, to provide the architectural concept and design of the building for the retrofitting, matching the plug-and-play facade features and technical performance indicators. The digital platforms, as the one we developed in the frame of the project, can further support the design and the industrialization if they are further improved to include features that can control and monitor the renovation steps so that further savings in terms of time and cost can be achieved. And if we further develop the plug-and-play kits of the Plural project using nature-based materials or fully recycled materials, we can have a concept that is fully circular, compliant with the circular economy principles in terms of recycling, reuse of materials. There are still several challenges, but I think we have opened up the road for these further developments. In terms of industrialization, we have found out during the course of the project that the conventional CAD tools are not adequate, and we need 3D models with high level of detail, as are the BIM models of the building and of the systems, of the components, of the P&U components. The supply chains for this type of off-site pre-manufactured components are not yet fully organized. All our manufacturers have a plethora of suppliers where they have to get their components from, and sometimes these supply chains are interrupted, like, for instance, during the COVID period that introduced delays, and it is good to reorganize these value chains to based on the local or regional availabilities. We have seen this in all 3 demo sites. The suppliers, for instance, for the Kasava demo site have been in the Czech Republic, the same for the Spanish and the same for the Greek demo site. The cost effectiveness and the sustainability of materials and components that we use in the prefabrication is a key element to make prefabricated components that are compliant with the circular economy. New business models need to be developed in order to take into account this fragmentation of the business, of the value chains, and the fact that you want to bring together from the design to the installation and monitoring a big number of different experts, which is not common in the construction sector. And the overall acceptance of this type of off-site industrialized prefabrication can be restricted due to lack of knowledge of all of the users, of the architects, of the constructors, of the developers. So having large-scale projects can be of benefit, and having long-term performance evaluation under harmonized standards can achieve economy of scales and reduce costs and improve the acceptance of this type of solutions. So just to close, we have achieved to show that the P&U kits are an effective all-in-one solution for decarbonized, adaptable, and regenerative built environment. We demonstrated the energy performance improvement and the improvement in the comfort, indoor air quality and comfort conditions of the renovated buildings. We achieved fast renovation with a relatively reduced disturbance of the tenants in the case the tenants were still in the building. And we have developed new approaches that could transform already industrialized prefabricated systems into green construction products. So I hope I didn't tire you very much. Thank you very much for listening. And I will never end a presentation without ending all the partners, each or one of you separately, for the constructive work and the dedicated collaboration. These are from my side. Questions, comments? I hope I was not very late. Thank you, Helena. So, according to the agenda, now we can have a 15 minutes coffee break to stretch out a bit, and then we will start with the individual work package presentations, the work packages that have been active during the last review period of the project, and we will start with work package 1. So the coffee is outside, please go on.
Yeah, I had a very late flight, and I was in Beverage.
That is the public one. Then, how do we we arrived at the end of the, I think it's the whole package presentation, the program of course. And of course we summarize like last time. There is no need to change in everything there. I fully agree with you. I mean, the purpose is to be able to show to the public the ones that we are achieving. One, and we can stop this one. Well, please think about it. Along the way, I have some comments. To start today, the idea is, and I think she was there. You had the communication. It's not necessary to be there. Very open. I wait for the changes. This is a good idea, but I don't know how. I think it's very flexible from what I understand, because officially, the project is and I asked them whether we should submit the financial statements before we said no. After the meeting, and after we make the corrections in the technical finance for aspects and everything. So I suspect it's going to be flexible. But we can talk this. We can talk. And actually, also from my side, I want to make sure because to get the audit certificates for the bank, I think that's a lot. It's not that we are not working. It's that we are Hello? So we continue the meeting with the presentations of the work packages, and we will start with the presentation of work package 1. The presentation will be done by the work package leader, Dr. Yannis Atsonios of the National Technical University of Athens.
Hello again. Here's the presentation of the work package 1. The work package 1 is about the definition of residential building requirement in order to achieve a fast and low-cost NZEB deep renovation of demo buildings, and the definition of KPIs that will be used in that was used in the project. So the work package 1 was established the framework of all project achievements. This work package was about the definition of main requirements for building typologies. We examined mainly the 3 real demo buildings, but the building requirements was also applied in unique building typologies in some cases. So the building requirements was defined in order to achieve the deep renovation by means of plural solutions, the P&U kits. To do this, we review all technical and market codes of plurals and review the certification strategies relevant to plural solutions. Among these, the review of all legal, ethical, and privacy monitoring requirements that also defined in this work package, and they help the work package 7, the monitoring campaign. Of course, the 2 milestones of this work package was about the definition of key performance indicators and the specification sheets of building of demo buildings. And in the frame of these work packages, we analyzed the retrofitting time and cost by means of plural solutions. Of these objectives have been achieved during the previous 2 review periods, except the last one that was about the rollout of go-to-market strategy. So for this, here is the Gantt chart of the work package 1. As you can see here, the work package 1 has 8 in total tasks. All tasks have been completed until the end of second review period, and the only active task for the 3rd review period was the last task, the go-to-market strategy. In total, the work package 1 had 8 deliverables and 2 milestones. So for the only one active task of work package 1, the task 1.8 was about the go-to-market strategy. Under the leadership of Phoenix and the help of technological providers, partners like NTUA, PNU providers, AMS, Denvelopes, RDR, and Require, and also the Intrasoft, IREC, and us, NTUA. The go-to-market strategy set the framework of the penetration of plural solutions into the market. So to do this, first of all, we analyze the current market situation by means of reviewing the trends of prefabricated and off-site renovation market. As you can see in the graph here, we have increased value in the prefabrication and renovation market for the next year. So we expect that in the following years, the plural solutions have many advantages in order to penetrate into the market. Also, we review all European strategy in the renovation market in order to achieve NZEB status of building, and also the market barriers that we analyze the current status of market barriers, taking into account the current situation of building market. Also, in this work package, we first analyze the exploitation strategies of the 3 PNU kits. The exploitation activities include the further optimization of PNU kits and the plural solutions, focusing also how to accelerate the construction processes. Also, a first analysis of value chains in the context of strategic innovation was taken into account. As you can see in the graph, the value chains activities were separated into primary and secondary activities. As primary activities, we have the inbound logistic operations, outbound logistics, and marketing and after-sales services, as well as the secondary activities regarding the infrastructure, human resources, technological development, and procurement. In the frame of the value chain analysis, the feature of each PNU kits was also mentioned here, and showing and highlighting how the PNU kits increases their competitiveness among the other solutions. In this competitiveness includes also versatility, cost efficient, and flexibility of PNUs. Last, the first analysis of PNU model, of a business model of PNUs, was also carried out in this work package. The analysis of business model used the lean canvas, explaining which is the problem and the solution approach, which is the current value proposition, and how will be the revenue strategy. Of course, all these results were also used in the frame of the work package 8 in order to further analyze the business model of the plural solutions. So for the previous task, we delivered the one deliverable, the D1.7, the go-to-market strategy, and submitted on time at month 43. There was not any changes or any risk. And the main achievement for this core package was about the go-to-market strategy and the assessment of the market potential and impact of the project results, and the identification of value chains and business model for the 3 PNU solutions. Of course, main input was provided by core package 8, and the output was also used again for the core package 8. So to conclude, here are the overall achievements of the whole work package 1 during the whole project period. The main achievement of this work package is the definition of building requirements by means of the review of technical codes, as well as the market application of plural solutions by means of market codes. In this work package, we analyzed the retrofitting time and cost, and we defined the pilot use cases by means of specification sheets. These specifications were significant for our simulation activities in the frame of work package 3 and work package 7. Also, by means of the definition of KPIs, we achieved to clearly define all needed indicators that are used in the impact assessment of work package 7 and the decision support tool of the work package 5. And also we review all legal, ethical, privacy monitoring issues that should be taken into account during the monitoring campaign at the work package 7. And the achievements regarding the penetration of these solutions into the market for further development, we review all certification strategies of PNU kits and the rollout of go-to-market strategies that I saw before. So here is more or less how this work package 1 was established, the framework for all work packages. By means of 8 tasks, the main outputs of each task feeds the other work packages, focusing on PNU design, on the technical data of simulation by means of specification sheets, the KPIs for the PNU assessment, monitoring, and the listed mod-based applications, and of course the strategies to market penetration of PNU kits by means of certification strategies and the preliminary analysis of business models. Overall, the PNU, the Work Package 1, have severe outcomes for the three different cases. For example, for the PNU design, we use the outcomes of Work Package 1 regarding the building requirements, the technical code, and the NZEB requirements. For the market penetration of PNU kits, we use the outcomes regarding the market codes, C strategies, and the go-to-market strategy. And also the outcomes of Work Package 1 was established the framework of other activities and other work packages, like the impact assessment by means of the definition of key performance indicators, the simulation campaign by means of specification sheets, and the monitoring campaign by means of review of legal, ethical, and privacy monitoring issues. That's from my side.
Well, no question, because I have some question, but I keep for WUPI 7 and WUPI 8.
Okay.
So thank you very much.
Thank you.
Okay, the next presentation will be by Jaume Colum of the Envelopes, and will present the final work done under Work Package 6, which deals with the manufacturing and assembly of the PNU kits.
Hello, we have been leading the Work Package 6, manufacturing and assembly of the panel unit kits. And we will present the works achieved during the last period review. About Work Package 6, just making a little bit of remembering. The objective and the achievements we had was, well, from the point of the manufacturers, develop a flexible and fully adaptable system for the specifications, international specifications, based on the lean management system, which I think it was really interesting, to for RISFAS from the envelopes, to introduce all this kind of concept, and apply it like more deep in our factories. It's been a good game for us. Then we also had jobs about assembly process for the panel unit kits, following this lean management, how this philosophy can be applied strictly on the new panel unit kits we were designing. We also had the task to produce the panel unit kits for the demo building, which means do all this job in our installations. Make all this development to be easy to be integrated in our places, which is also very important in order to be able to do something that once you have, if everything goes well, be able to put this on the market and to sell it. Of course, we also, when we talk about manufacturing, the quality assurance plan, it's also very, very important. You are trying to do new things, and it's very important that you can check it under a quality approachment, that everything is going to be good and with the best quality. Of course, this is also related to the production of installation methodologies. What we produce had to be easy installed in order to achieve the project objectives about make it fast and cheap. The panels must be cheap to produce in the factory, but also has to be cheap to install and even fast. So it was really complex. It was a really ambitious objective, that we achieved. And then develop a range of in situ testing. Of course, validate what we did. There was a good teams following the installation of the panel unit kits, and a large, there has been many works testing that what we have done is great and accomplished the objectives. And then after all this experience, provide technical information and recommendations for the future industrialization of the plural kits. Yeah, it's funny, because during these 4 years, technology have like improved, and yeah, there is always ways to improve what we do and to do new things, and you have never you cannot stop never about thinking about how to improve what you do. About the Gantt diagram, well, we have followed the Gantt. We had some few delays. Maybe the worst one was in task 6.5, which we are presenting right now. It is the task that was active this last period. And it was delayed due to we haven't not finished the demo sites in Cachava and in Terrassa. And also the document we present was not balanced with all information from the 3 demos. So we work a little bit more, and we wait to have all the data, and we updated this last September 24. Well, the active task we have been doing this last period was 6.5, future industrialization of panel unit kits and guidelines. And yeah, the task objective that were marked in the project was manufacturing and assembly installation process. Well, this task is like a few resume for future investors, to understand what we do and how it can be easy. I mean, exported or produce it everywhere. So it's normal. We have to explain the manufacturing and the assembly and the installation process, like a resume of what we have done. And very important, with knowing it for sure, because we have done these demonstrations and we have this experience, and now we can explain that we have one example done, and that this has been a great opportunity to learn a lot. So if now we can find more projects, for sure that having this work done is the best way to give confidence to future customers. And then the task also is proposing new cutting technologies for the panel kits installations. And well, yeah, you will see that during these years, and when you are trying to solve new problems like we've done in plural, there are always like new horizons, new standards that we can achieve in order to keep improving keep innovating our systems and the construction technology. And then this task also has a work about estimate the initial benefits of the 3 demo sites, according the job we've done. That it's just estimations that later in task, maybe it was like an output for the whole package 8, in where we have tried to demonstrate in more accuracy and numbers these estimation tables. The going results were these both in whole package 8 for the business model and for the business case analysis and assessment. The guideline for task point 6, well, maybe I have explained now, but well, we did this, we put a quality resume of each of the panel unit kits to generate this interest in potential manufacturers. And B, new coating technologies. Maybe for me, it's the most interesting part of this task, about how this is like for a manufacturer. This is like dreams, If we could have this in the factory, we could do like everything easy and fast and cheap, Of course, it's like a very high step, but yeah, self-driving construction vehicles, many factories has it. It means that you have a very big factory, which is not our case maybe, because we are just in the beginning, and we are not at that standard, but this could help us to produce very cheaper and better quality. Augmented and virtual reality. Yeah, it's all about 3D printing, no? About the digital skills, no? Even now with IA, on the last point, it is now opening a really big cloud of things that can be integrated in the design, in the production factory, in the linking to other chain factory of your providers. It can be crazy, no? In the future, if we can do something that everything can be linked together, no? We could win a lot of production time, reduce cost, improve quality. It would be amazing. But this is a good thing now. This is opening right now, no? But yeah, it's been very interesting. Then robotics, of course. There are always a few assembly, no? We need workers, and robotics can assist on that place, no? And use people for the more qualified works, no? Then and the rest. Here, the other part of the task, it was like doing an estimation of. Yes, please.
Can you go back to the
yes.
previous one? Well, I think that is quite interesting, these new cutting-edge technologies that you have included as a new chapter in the deliverable. However, you have only 2 pages, and it's mainly a list. If you are focusing on investor, I think that you should provide at least a summary about which one of these cutting-edge technologies has been used for each kit or for each installation. Not necessarily here, we can keep the deliverable as it is, but I think that it will be really useful to jump into market to include these new cutting-edge technologies, a more detailed specification. This is my point of view.
Okay. Okay, thank you. We will. I mean, and then here, the time saving estimates, no, for the 3-panel unit kits. I must say that this is an estimation. No, you try to be realistic, but of course I understand that this also is like something maybe a little bit subjective. No, but yeah, about. I mean that more or less both we have coincidences, no, both systems about measurements and the zinc that we can achieve really reduction time and cost due to the digital skills. The permits and approvals, no, this is more like complex because permits it's always related to the technicals of the city halls. And yeah, if they were like fast, no, it could be just a great achievement to have more speed. But it's also, I mean, we have the chance, like since the plural panel kits are designed as external cover, it should be understood like it's more like paint a facade. No, it should be something easy and fast to give a license for the permissions. And engineering. Well, of course, and logistics and fabrication, and these 3 are about lean manufacturing, doing off-site systems, and we know that this increase the speeds, no, of course, because you accumulate the work in the factory and then you fast install one day in the on-site, and then also, of course, for the on-site renovation speed and the cleanup. If they are precast systems, all assembled dry, and they also give a good estimations. No? Deliverables and millstones. Well, we had 5 deliverables and 2 millstones. Well, the 6.1 we were delayed 1 month, and the 6.2 it was okay. The deviations we had in this period, it was 6.5, already explained in the beginning, no? We had to harmonize all the steps for the 3-panel unit kits, because when we delivered this, Terrassa and Cachava, the installation were not finished, so we will wait and we improve information. And contingency, the risk we had, of course, we couldn't do better 6.5 when we presented because we don't have finished these ones. And in order to keep going all the project, we decided to put some of the information in 7.3 and 7.4. So, and from then use this for the Work Package 8 tasks. And achievements, well, maybe I will repeat a little bit from the beginning, no? Because the objectives we had, at least we have achieved it, no? We have, like in Work Package 6, at least we have make a good description of the final plural panel unit kits. Good, very accurate description, of course. Installation description, we had done a full range description of the process installation, and we have validated this after doing the demo jobs. We had demonstrated, because we have produced the demos, that we can integrate this in our manufacturing lines. We have been able to evaluate this production. No? I mean, Plural Project has given us a really great opportunity to test, no, in a big, larger scale, something new, and that's the best to gain data and to be sure that you can try to sell it again. No, that we have been able to do this job. We have. Talk about steps towards future industrialization, no? Well, how can this scaling up? And the cutting-edge technologies, no? Highlights for innovative technologies, approach to the future potential improvements, no? Well, contribution to the overall project, well, design of the systems, is integration in the factories, is contribution to the installation methodology, no? From our experience we had in production of site systems. Also, contribution to the manufacturing methodology to reduce costs for panel unit kit fabrication, no? This is always interesting for a manufacturing. If a manufacturer tries to think how to reduce costs, how to be more competitive. And it's very interesting because this work helps us to make new inventions, which are not what you don't see maybe in the final process, in the final result, but it's important for in the chain and the production and the manufacturing chain. No? From World Packages, we also have the mock-ups and all the large production for the demo. We have done good quality. Of course, we know all the costs, the assembly times, etc. No, and we have proposed new cutting-edge technologies. No? Once we done, no. Once everything is done, it's easy to say how we can, what you could do different or what you could do improve. No? And that's all. And questions and answers.
Hello, no, I keep my comment, but we can come back at RV8 because we can put this information in the business model related to industrialization.
Yeah, okay.
I think. Here, as general comment, this deliverable that is a public deliverable lacks a bit as a good summary about its kit, but again we can come back on good.
Okay, I understand. Okay, no, thank you, Elena.
Okay, now we come to the core work package that has been active during the last year of the project. It's work package 7. We have structured the presentation of the tasks as follows. Letiana, as work package leader, will make a presentation of the overview of the achievements of the work package, and then we will proceed with the presentation of the monitoring methodology and campaign that has been developed for each of the 3 demo sites, and from there on we will go to the presentation of each demo site separately. We will start with the Spanish demo site first, then the Czech, and last the Greek that will be presented after lunch. So Letiana, please go on with the overall review of the work package 7.
Okay. Hello, everyone. So I was introducing my colleague, Marita. She is online. She can be available with us here today. And to begin, this was a huge challenge, this work package. The main objectives of the package was implementing the solutions, no? So demonstrate the building innovations. Also, these 3 demo sites with the model license, the 2 that we had to monitor the performance of each of it, assess all the data that we had with the innovation, identify the social and environment impact, no, about the solutions, and also the viability, the financial viability, the technical viability. It provides some recommendations and guidelines for future. No? We had 7 tasks that was at the beginning of the preliminary design about the architecture and everything about also the units, the installation of the 3 demo sites. So we have also the part of the monitoring and the modeling of each demo case, the campaign of the monitoring that will be seen before this presentation, and at the end, the viability of the assessment of the solutions and the monitoring that we had. The deliverables and milestones that we had 3 deliverables and 1 milestone, which we almost deliver all in the time. We have to submit the Cassava and the Barcelona deliverable because the tasks extend with the renovation was larger than the previous expected. And the last one, the milestone that we had, we did the deliverable 7.6 that we finalized in the end of the project. Okay, so the risks that we had was majorly about the extent of the renovation timeline in Cassava in Terrassa, and also the 7.7 that we had missing periods in the post-monitoring that was replaced by simulation. And some of the user experience that data that we had goals in the beginning of the project that we didn't have to amend in the end of the project. So this was a little bit overview of the work package. And now we pass to Jordi. Can I put here the presentation? Is 4, no? Okay.
The next presentation will present the methodology that was developed for the monitoring campaign. This methodology was primarily developed by the group of IREC, and Jordi Macia will make the presentation together with Angelos Milonas and Jordi Pascual.
Thank you, Maria. I will very briefly explain the monitoring campaign. We designed a monitoring campaign, and the objective of it was to measure all the KPIs and key variables for each demo site, which allowed us to monitor the good functioning of each demo site and also calculate the final KPIs for the assessment. The task was led by us, IREC, but with the contribution of Intra regarding the monitoring platform, the dashboard, where all the variables were stored for all the demo sites, and also the collaboration of each partner responsible for the systems and the owners of each demo site. So most of the partners of the project contributed. The planning was in 4 phases. In the beginning, we had to design the systems to be installed in each demo site, the sensors, the systems, the frequencies, and also prepare the LYSYS platform to be able to receive data from many different sources and to present them in a uniform way. When the system was ready, then we started the pre-monitoring, which was initially supposed to be for all of the demo sites 12 months before the renovation, so we could capture the previous state of the demo sites. Then we had a period for the renovation, the break, where the plural solutions were installed in the demo sites, and afterwards we had another period of 12 months more to measure the result of the demo site. So they are comparable periods. And finally, to assess this data. Regarding the acquisition structure, as I said before, we had 3 different real demo sites and with different systems, different sensors. We had to find a way to collect all of them into the LYSYS and to present them uniformly and available for all the demo partners. You can see here okay, they don't have the pointer, but in the left side there is the screenshot of the LYSYS platform where we could select the variables to be monitored and for which period of time. And in this scheme, we can see that between the sensors in the real demo site and the LYSYS, we designed somehow different intermediate platforms where we could. Here's the pointer. Oh, thank you. Thank you. Yes, so where we could intermediate platforms that could communicate to the sensors, store these values, and then afterwards send them to the LYSYS. Here we have some screenshots of the LYSYS portal. This is the welcome screen. Afterwards, we see we can visualize the database by its individual entries, and then we can filter them as selecting which demo site, which category of measurements, either they are energy, indoor environmental quality, or weather conditions, and for which period of time we want to measure them, because it also presents aggregated values, daily average values, or hourly, even sub-hourly measurements. And here we have some examples of visualization. We will see more later, but you can, because there are more than 200 variables in the whole project, so we cannot see them all. Also, the LYSYS platform also stored the MODES platform, and the MODES platform is a recommender application, which you could select different technologies, and this was a tool more thought on in terms of design. So you could very easily select one technology or another of the plural platform based on the demo sites, which as a base case, and you could see very easily compare the effect of one technology or another. Okay, and going more into the specifics for each demo site, we found that they had particularities about the execution of the renovation works and we had to adapt to them. So what was the initial planning, it was made flexible, also according to the specific measurements we had to do. So this we were adapting for all of them. For example, for the Kashava demo site, the monitoring started on the 2nd July 2022 and ended by the 28th of August 2023 when the renovation works started. And afterwards we had some provisionary measurements on the site after the renovation work started. And for this place we had to measure 2 apartments because there are the first floor and the ground floor. And each apartment we monitored 3 zones in each of them, 2 rooms and 1 main room. And also we had measurements of the weather station and the photovoltaics installation. Also the measurements changed from when we had the pre-plural situation and the post-plural, because in the beginning we had gas consumption, we had an electric tank for the domestic hot water, and also the indoor environmental quality for each room. But when we went to the post-plural, then appeared a heat pump and the photovoltaics. So the measurements had to change. We had to communicate with more sensors and adapt the platform to acquire more measurements. And there are some of the images of the weather sensor installed in the roof, the gas metering installed in the gas incoming in the house, electricity meters in the main incoming, and also more specific load meters. And here we have some examples of the monitoring in the LISIS platform. For example, this is the aggregated electricity measurement of the first floor. We see it's accumulating, so the value increases. Here there is a step because there was a little gap in time that for some communication error we could not measure this period of time, but we were aware of that, of course, and we solved that quickly. Also some indoor environmental quality, such as the temperature of one room or the CO2 levels of the common room of the first floor. Yes?
Here I am a bit confused about the differences between pre-monitoring and post-monitoring.
Yes.
If I understood properly, yes. Post-monitoring is only 3 days, is an uninhabited building. You have kept solar shading and ventilation switch off. Is like this? I understood properly?
For the post-monitoring of Kashava?
For the, yes, yes.
Yes. Okay. Daniel says this.
Present this under the demo site presentation.
Yes.
It will be made.
I will present it later.
Okay, then what I should like to know is what are you comparing with the monitoring between pre and post, after we discuss
yes,
about? Okay,
we will enter into
thank you.
particulars for each demo site in the assessment. This is just to show that the monitoring system was designed, installed, and we are acquiring data in a different schedules for each demo site. This is the example of Terrassa. The Terrassa works started, okay, the monitoring started in the 2nd July of 2022, when there was not even people there. And we monitored until the moment of closing the assessment of this project. This is 22nd October of this year. Here we monitored more apartments, 6 of them. Each of them has from 3 to 4 zones, mainly bedrooms, a common room, and some other have an extra room such study. And also we installed the weather station and the photovoltaics measurement. The differences between the pre and the post monitoring systems are mostly the same, but here we, instead of using thermal solar powers, we included the photovoltaics here. We have the picture of the weather station installed in the rooftop, some indoor environmental quality meter, and the platform acquisition, the communications platform. the communications gateway installed in the under the roof that was collecting information from all the sensors and sending them via a GPRS router. How do we compare? Yes. This is the systems that we had to measure. For the case of Preplural, we were measuring this. No. This is what we had to measure. You will see later how we. Actually, the thermal solar panels were not habilitated when we started measuring. Okay, this is some data we recorded, either for the electrical consumption for apartment 2.3. We see that it was not occupied until this is August 2023, until the current days. And also some measurements of indoor temperature, which also you can see that starts the occupied life. And the same for the CO2 levels, which are ambient CO2 levels. And when the occupation starts, we have some levels here. And this is solar radiation from the weather station. And regarding the last demo site, the full demo site, the monitoring work started very early on the 4th April 2022, and they were running until the moment of the assessment, that this October of this year. We have a data gap of 20 days between April and May. We were aware of that, and we tried to solve it as soon as possible. Here, there's a mistake. There's only 2 apartments with 3 zones each, and the photovoltaics and the weather station. And here we had, in the beginning, only an electrical boiler and portable heaters. And in the post-plural, it also entered in the heat pump and the fan coils for the smart wall and the photovoltaic system as well. And here we see the weather station, some portable electricity meters for the different plugs, and the indoor environmental quality, which is this one installed in one of the rooms. And here we see this is an aggregated electrical consumption, but with the different components regarding the heaters or the domestic hot water or the appliances consumption, beginning, as we said, in the April 2022 until nowadays. This is 1 year example. And this is the weather measurements. And okay, as technical challenges we experience it, of course, when you go in one of these complex situations, we have many data sources and different origins, then you find that sometimes there are interruptions because there is no communication, or some of the sensors go off, or maybe the users interact with the sensors and then you have some wrong measurements. To do that, we installed some automatic alarms, let's say, some thresholds. When we detected a period of time with no incoming data, then an alarm was sent, or if some thresholds were detected, outliers or rare values, also we were warned and tried to fix them as soon as possible. And also we were keeping periodic meetings with the responsible partners for each demo site, the technical partner and also the owner partners, to check that the monitoring period was okay and that the measure values, they had a sense we were measuring something reasonable. Well, as you saw, we had a plan in the beginning of the pre-measurement data and the post, but then the works and the reality went differently. So we had to adapt for each demo site, when to change the acquisition from the platform, or even which measurements we had to do in the end, finally, yes or no. You will see that later in the assessment, but for this, some of these data gaps or these incomplete post-plural periods, then we record to the simulation strategy, mainly for the sites of Terrassa and Caixaba, as we will present afterwards. Well, I would say maybe to underline that the equipment was, the monitoring was installed and satisfactorily run for all the demo sites, registering the energy, indoor environmental quality, and weather for all of the demo sites, adapting to the circumstances of the demo sites. And also we could manage to gather them all into one platform, which was uniformly presented for all the users. Okay. In the assessment, we will come more into the particulars about how do we manage with these gaps or these incomplete periods. And that's all. Any questions? Thank you.
There are no questions at the moment. I would like to stress that this task has been really important for the success of the project. Without this task, we wouldn't have been able to harmonize all the data that were received from the different demo sites. And as you will see in the next presentations, monitoring is not a trivial task. It has a lot of challenges and difficulties that have to be overcome in real day life.
Can we begin, Maria? Can we begin? Can we begin? Yeah? Okay. Okay. So we're now gonna to start with the Terraza demo site. We are here, Jordi, Marta, and Angelos, that will help us to explain a little bit how was the process. So the objective was demonstrate the viability of the developed comfort walls. The demo site was in Terraza, in Barcelona, and the actual timeline was M48 in April of this year to September of this year, almost 1 year before the initial date that we had. So the key outcomes that we had was the installation of the innovative system, heat and demand reduction by 19%, the total primary energy decreased by 30%, and we had passed from Spanish energy certification from E to A with this renovation. This is our overview about was good looking, the building is right now. A little bit of overview about the system that we had modular and adaptable in the lightweight and large-scale prefabricated facades. There was acoustic and thermal insulation also. The ventilation system integrated with the panel, the photovoltaic tiles, and also the louvers and the window integration. That all was all fabricated in the envelopes headquarters. So here a little bit of the system that was used with 3D modeling to precision the structural and adjustments. The production was with the CNC machines, and we have the installations all prefabricated and pre-assembled in the fabric with all together, and then the transportation was done by the trucks to the site. A little bit of technical challenge that we had, and when the beginning of the installation of the panels, that we had to adjust some profiles with the PV that we can see in the picture, that we had, here, a little gaps. Also, which is innovation system, we had a little bit problem with the workforce training. The alignments of the photovoltaics, and also here you can see that we have to adjust these parts of the system because mouse intrusion that would occur in the end. No. Also, some problems with the windows, with the how you say this in English? I don't have shooters. Yes, here, and we have to optimizing the installation. Okay.
Excuse me, did you keep the old windows? I think.
Yes. Yes. We keep all windows and put another one to the envelope. Yes. So here we have some adjustments that we had, the Windows profile that I did. Here. So the final timeline was that we had to adapt it about the problems that we had with the tender and also with the administration license. Here a little bit about the process. So we have the panels in the fabric and the installation of the panels, then transportation and also installation in the site. Here are the areas that we renovated. So we have the frontal facade of the terraza that is in a street, and the interior facade was made by Ethics and not using the envelopes system because we had a problem with the crane that did not enter in the interior of the building.
Here I have a question. The envelopes is west facade and the east facade has been developed at the same time or not?
Yes, the construction site was, yes, the monitoring is everywhere.
At the same time,
yes.
Without and with the U value similar for the two of them?
Yes, yes,
okay.
yes. The envelope was, the construction site, there was, all envelope was assessed, was renovated.
But I think that there was previous renovation.
Yeah, but this
yes.
No, yes,
this is not. This
no.
is included in the same time. Or
yes.
Yeah. Okay. Yeah, correct.
We'll see in a final video. So here, the installation process and how it was finished. And here is a before that we had a little bit of works, but it was like someone about paintings and not thermal changes in this phase. And after that, we had this presentation of the building. Now I pass to Angelos.
Well, during the Terraza monitoring campaign, we monitored in total 6 apartments, 3 in the first floor, 1.1, 1.5, and 1.6, and 3 in the second and third floor, 2.3, 2.5, and 2.6. On the right-hand side, you can see the apartments highlighted that are monitored. So in each of these apartments, the monitoring equipment was installed in the living room, the main bedroom, the small bedroom, and the study whenever one existed. This is an overview of the monitoring equipment. In the top 2 photos, you can see the indoor environment quality sensor that was used, and it was manufactured by CVUT. The bottom 2 photos show the weather station, and the photo on the right shows the communication system, which is responsible for transmitting the data from the demo site to the LISIS platform. In this slide, we present an example of the acquired data. In particular, data collected between July of 2022 to October 2024. This data is all available in the LISIS platform. Regarding the energy measurements, the monitoring interval was set to 15 minutes, and the indoor environment quality measurements, the interval was set to 5 minutes. Regarding the assessment now, the model calibration was performed based on the apartment 2.3, and due to the fact that we only had 2 months of post-plural monitoring data, the strategy we adopted in order to evaluate the building behavior was via transit simulations. Thus, we developed 2 models, one before the plural renovation and one after the renovation. Here it is important to clarify that the Terraza demo site falls under the social protection program, which means that tenants are characterized by energy vulnerability. This was also confirmed by the monitoring results, during which we observed low energy usage and bad indoor environment quality conditions. Also, during the monitoring campaign, apartment 2.3 demonstrated the best results in terms of occupant behavior, regular patterns, and indoor environment quality conditions.
RV3 monitored dwellings who has answered the social questionnaire.
Sorry, can you please repeat?
Here you have these
Yes,
dwellings.
yeah.
And when you arrive to the social impact,
Mhm.
you have this answer
Yeah.
from Terrassa. Are the same people?
No, the
There were anonymous questionnaire.
We don't have.
We have correlated some according to what we think it matches, but we are not sure about.
Yeah, about, for example, no, how many people were
Yes.
living inside, so we tried to...
And the schedules.
How many apartments have been restored? Restored.
the energy renovation, all of the building.
The 19, the entire building.
Yes, but I will explain later. Only 2 of them have the full solution, including the ventilation unit.
Yes,
But the
because
rest-
there are 2 that have east and west facade. Okay.
Not 2,
No, it's first floor, second floor, under
and under
the roof.
Yes.
And what I read is that 2 of them were quite similar.
2 of them.
Between them. That
Sí.
do the comparison between these 2 apartments.
Yes,
or I
but they
misunderstood.
are in the same side. They are in the east side of
They are shown here, the ones on the left-hand side.
Yes.
They are apartments on the first floor, 1.1 and 1.6. So for the transit assessment, we adjusted the building model we developed in a previous task that we used for NZEB certification, and based on the monitor data of the pre-renovation period. All the adjustments were based on the mostly related to the occupant behavior. And based on the monitor data shown on in the graphs here, we extracted some occupancy profiles. Then we made some slight adjustments to these profiles, which were later introduced to the transit simulation with the monitoring data. After finishing with the simulations, we had to evaluate the results. So we did this against 3 distinct established criteria, which were set by ASRAE, by the Federal Energy Management Program, and the International Performance Measurement and Verification Protocol. What we chose to compare was the indoor temperature and the heating demand for all the zones of apartment 2.3 on a monthly and hourly basis. As it can be seen from the table, the simulation outputs comply always with the criteria, since they fall below the predefined threshold. After the pillar renovation, we had to fine-tune the building model a bit to the new properties. For this, we adjusted the air tightness of the building, since the whole facade was improved. And we also incorporated 6 ventilation units, 1 in the living room, 1 in the master bedroom, 1 in the small bedroom, for both apartments 1.1 and 1.6. The 2 graphs here present the monitor data collected during the 2.5 month period of the 6 ventilation units. And again, based on data of the post-plural monitoring period, we adjusted the operation of the 6 ventilation units in order to better depict the real operation. So we measured the ventilation rates, and from there we extracted some profiles, which were later implemented in the post-plural transit model. The graphs present in blue the monitor data, and in orange the synthetic profiles we created. I think we'll continue here.
Thank you. So we saw the calibration process. Now we will see the results, the assessment itself, because the results are calculated for the apartments 1.1 and 1.6. This is maybe you were asking about them. They are in the same facade, and those are the one which include the full plural solution with the ventilation units. So each of these dwellings, they are symmetrical practically. They have a main bedroom, a small bedroom, and a common room. Also, and two non-condition zones, which are the kitchen and the bath, but those we are not monitoring them. And this is the detailed transit model we made for both of them. And the results are mostly similar for all of them. You will see we kept with the calculations, but the results do not differ practically. So we present them average between the two dwellings. And these are some of the results pre and post renovation. This is the simulation made for the same weather period, starting August 23, ending August 24. I mean, because it is a little bit abnormal period. In the middle, you don't see the summer. You don't see the summer season, but you see the heating season. So you find the summer season in the ends of the plot, and we can see here that, of course, appears a big demand on the cooling, because in this initial status there are no cooling systems. So now we have the ventilation units which can supply some some cooling power. It's not a big power, but it helps to mitigate the comfort conditions. Also, of course, the ventilation consumption passes from 0 point something to 6% of the consumption, because now we are renovating the air inside. Also, we find that the heating it's decreasing from 195 to 158, and this is because, despite we are renovating now the air, the building now is more passive, has more insulation, has better air tightness. So we find that the heating demand decreases. And the domestic hot water and the appliances, of course, they stay the same, because we apply the same monitored profiles. From the apartment 1.3, we apply them here in these other two apartments. If we go to the KPIs, well, we have to begin taking into account that the initial status of the building was already very good, because we had total consumption of primary energy of 60 kilowatts hour per square meter a year, which is a very good level. Actually, we are under the threshold of the Spanish regulation, which is for this climate zone, it is 76 kilowatts hour. But we have to take into account that we are using these monitor profiles which correspond to vulnerable communities, energy vulnerable communities. So sometimes we found that they are not in comfort, or in general they tend to allow a consumption profile. Also, the heating demand of the building, we found that because of the thermal conditions of the building, let's say the passive, the insulation and the compactness of the building, we find that the initial heating demand was 4.09, which is very low. Okay, so having this in mind, that we have a starting point, we also, the introduction of the plural solution resulted in this. As we can see here, there is a reduction in the heating demand. Of course, there appears a cooling demand, which was not existing, and also a higher ventilation demand. Lighting, appliances and domestic hot water stay the same, and now we have the PV production.
How do you feel that it matches with the poor feeling of comfort? The comfort index are not really good for Terrassa.
The comfort, sorry?
The Fanger index that news that
yes.
in the deliverable are not really good.
We go into the next slide, into the comfort. Okay. Now we are about the energy results.
Really good. I don't understand why the comfort is not good.
Well, especially it's not good in summer. In winter, it's not that bad. We will see now.
Winter in Barcelona is not a winter, really.
It's not a severe winter. No. So that's we see we have a low heating demand already. This is the starting point, but still we try to improve it a little bit.
Because for me it's a big strength that you have KPIs very good for energy and not good for non-for.
But the comfort is more related to the air qualities, and also because of the cooling, because in the cooling actually is very, the building is very hot. But I will present now in the next slides. Here only, because there are no cooling equipment, and then appears. I don't know. We see it now. Just to finish, the total primary energy, you can see that decreases the consumption from one situation to the other, and this is due to the apparition of the self-consumed photovoltaics. Also, the delivered energy, which repercutes in the total energy bill of the building, also decreases. And of course, we have an increase in the renewable energy ratio from 16 to 36% due to the photovoltaics. Okay, now going into the comfort. So what we see reflected here is that now we have a cooling system. The air is being renewed. There is a higher thermal insulation, and the facade now is more air tightness. So we put here the threshold, these lines in the 0.7 PMV. So for the 3 rooms, most of the time we are within this threshold. And between the pre and the post, we don't see much differences. Yes. Actually, there is, if we measure, this is 0.7 is category C, but we choose as the KPI of the project, we choose category B. So there is a little bit of decrease. And this is because we are renovating air now. So we are introducing more fresh air. So a little bit decrease in the temperatures we can follow here. But, and also the heating equipment and the schedule that we adopted, it didn't allow us to deliver more power. So maybe if we could use a profile which was not related to energy vulnerability, maybe we could fulfill with the extended heating schedule, we could fulfill all of the comfort requirements. And this would not be a problem at all. What we see here clearly is the difference between cooling. Still is not a satisfactory situation. We achieve only 24% in category B, but we were unexisting practically in the beginning. And this is due to the ventilation unit that provides cooling, but also it's not a cooling unit, it's a mitigation unit that it's helping with the air renovation. If we wanted to have a full comfort in cooling, we should provide a heat pump or cooling equipment, proper cooling equipment.
Okay, this is a question for architects. I think that maybe this double window is a problem for overheating in the summer, because you have the envelopes external window and the internal that was the old one, I suppose. Very simple window, I suppose. Well, then maybe, but it's a theoretical question. Maybe this double window is somehow a problem for the whole envelopes system, because it creates some undesired overheating. This is, well, maybe, I don't know if you monitored this space between this solar collector, west solar collector, that is really a hard situation. Then I don't know how did you solve this issue, if you identified this problem or not, or maybe you didn't identify this problem.
I will show more later on the presentation. And in the beginning, the main idea was In the beginning, we had the main idea to also improve the overall windows square meters, and also to put just one window with more efficiency. But with the problems that we have with the installation and the tender and the construction enterprise, it was defined that we keep the same windows that we had and put another one to help with also to deliver the U value that is needed by the Spanish code. So if we had just the first window, we can agree with the Spanish code. So with the two windows, we have the U value that the Spanish code requires. About overheating, I entered in the project this year, so I did not was in the beginning of the project with Felipe and Susana, but I know that in the beginning the main idea was to put just one window with more isolation, 2 glasses, thermal bridges, and something like this. And in the end, we had some budgetary issues and technical issues about the crane and everything, and the idea was to put the 2 windows to comply with the Spanish code and also to comply with the winter solution and make all the envelope one unique structure. So I see that the windows maybe can be a little problem for the overheating, but we can open it so to enter the wind.
This is maybe for Jaume. The final solution, your envelope solution is with one window, with one envelopes window, one system, or you keep this double window in the system? No. What is the scalability of the final system?
Oh, my point of view is just regarding each, we install one window. If our customer want to stay with the original one, then you can supply another one, and you have 2. For me, I prefer this solution because you don't throw the old window, you reduce the wastes, and it's like you create less disturbances to the users when you install the system. If the customer would like to renew the window, we just have developed a system to pre-install a window in our system. So for me, it's just leave what the customers want. I don't understand the system or what I would advise to my customer if you prefer 1 or 2. From my point of view, 2 windows I like more than 1, but maybe.
Time and cost that you have provided are related to 2 windows.
Yeah, but
This is my question.
no, but it's the same because we don't touch the one window.
Yes.
Anyway, we install one window.
It's less expensive if you don't touch, you don't get
Exactly.
waste,
Yeah. You speed the installation. Yeah. And now the data is with 2 windows. Yes.
I think, Elena, that for further installation and other systems is also, we say in the beginning, it depends of the building. In this case, this was the main idea in the beginning, and it was the best solution that they keep in mind, the cost, the timing, and also to not put away the windows that we already have. So if Jaume wants to put in another building, have to assess the building and see if energetically we'll do fine with 2 windows or 1 window or a more complex window. No?
Keeping in mind that this solution for is a retrofitting, is always a retrofitting solution. My question was, the final product is with or without, but it depends.
Yes.
It depends. Okay. Thank you.
Just a small comment. In terms of the new trends of circularity, keeping the old windows, it's a positive step because you don't waste, you don't create waste, and you don't create, and you can improve also the.
It's more plug and use.
Yeah. And something that it was not mentioned, that the questionnaires and the response that we had were from a very short period of monitoring. So it is not easy to assess whether there was really overheating due to the double window.
Okay, just to finish, I resume from this point, and I will add only that having a more compact box plots, let's say, with less variability of the indoor conditions, also it's positive for energy vulnerable conditions. You know? You make it a more resistant building to the external conditions. Okay, the last slide about the comfort. Here, instead of, we see the PMV, but also now we see the relative humidity and the indoor temperature. And maybe this is the question you had. If we look at the heating, here down, these two situations, the pre and the post, we cannot observe the distribution of the temperature, only we see that now we have less points below 20 degrees, which is positive, it's hotter, but also we can see the effect of the air renovation. No? We get here some condensation situations maybe, and a lot of very high relative humidity indoors, and this is a clear effect of the renovation. So it's also a point to improve the comfort, even the temperature distribution doesn't change a lot. And of course, the variation on the distribution of the cooling is very important, because at the beginning we had temperatures below 31 degrees, and now the 31 degrees is the limit, and more temperatures around 25, 24 are present. So it's also interesting to note. Okay, and just as a main conclusions of the assessment from the energy and comfort point of view, in the energy point of view, we can say that the general performance of the building improved, because from the heating point of view, we reduced by 19% the demand. It was low already, but still it improved. The total energy delivered from the grid also is reduced 18%, which is a reduction in the electric bill for the users. Again, in this context, is a positive thing. And the total primary energy decreases by 30%, and despite we have no more consumption, because there is cooling and there is ventilation, the introduction of the photovoltaics and the self-consumption reduces the overall primary consumption by 30%. In terms of comfort, of course, cooling, it's clear, no? We had no cooling, and maybe this overheating situation, and now we have some mitigation. We are 25% in category B, and the heating stays, despite we are renovating more, the heating stays in the C category in its majority. And of course, we see the effects in the relative humidity. So we had some 100% situation in some cases. Now we are everything below 70%. And also we couldn't measure, because the simulation didn't allow us to have the CO2 and volatiles measurements. But of course, introducing a renovation in the air has a positive effect in the concentration of contaminants and in the indoor. And just a global conclusion: if the introduction of the plural solution also helps, contributes to make a more resilient building to the external conditions, and decreases the electric costs for the users. So everything is in favor of users from the energy vulnerable communities. And that's all regarding this part.
Okay, so we already say a little bit of this, but the deviations of the beginning plan was we had original timeline for 2013, and we had a lot of delays because of the permits that we had from the city halls, and also the tender process that we had problem in the beginning. So we did start the construction in April of this year. Also, the problem that we have the access, about here inside of the main island, of the building, that we cannot access with the crane. So for this, the decision was made to not install then the envelopes in the interior building in change for ethics outside. And also the windows, that in the beginning was planned to change all the windows and put another ones. And the solution about this design was also for the time and the budget to keep the existing windows and place new ones, one internal and one external, Okay, let's pass. So the risk and containment plans that we had and the beginning of the installation is not common in Barcelona, but we had a frequent rain during the construction, and this was a little bit delayed in the timeline. And the airtightness and the windows, we had to customize profiles that we had not planned in the beginning, that we had to adjust in the work. Also mentioned before that we have limited expertise in the system about the workers. The budget and the tendering, that we had problems in this delayed the installation, is the technical issues that we mitigate, that the crane construction and safety concerns that we had with the interior facade. The main achievements that we had was the first registrable cladding facade system, that we had here a picture that we can just like plug in and use, the innovation on this facade and innovation that we are scaling with insulation, louvers, PV, ventilation units in windows, all together in just one prefabricated model. The air quality that we improve and energy performance that Jordi already mentioned, the integration of the PV, and also a system that is future ready to put in the market. Here's some KPIs that we achieve. So Jordi already said about the energy, the technical that we have. We can increase the certification by 1E to A. Also, the EU values that we comment about the building, we have lowered a lot in this technical intermittent transmittance. About the LCA, we have the ETEC that they have the numbers that they put here for us. It is a solution that is 10% disassembly. We can take from here and put in another place. And we have achievement in comfort, most in cooling, in heating, sorry. And the renovation time was as planned, more or less 4 months. If not raining, it will be a little less, I think. But it's a system that we can do in a lower period of time. Marta, if you want to...
Hello, everybody. Very briefly, I'm going to explain the user engagement and feedback from users too. So we start explaining the Plural project to the new users in July 2023. Before the starting the implementation works of Plural Solutions in Terrassa, we did a new meeting, but in this meeting there was not a lot of users because it's always difficult to have users together in one room. So we developed a short video explaining how the solutions will be implemented and little planning and so on. So after that, we send to users the questionnaire, the survey that Phoenix provides. We include some questions that IREC provide too in order to know more about how they use the dwellings and appliances and so on. And we have to explain that the constructions work end in the 25th of September. So due to the plural project was in the end, we send the survey just 1 week, 2 weeks after the construction, the implementation of solutions ends. So you can see here the main answers. Well, we had only 6 answers, so less than 50% of the tenants, but mainly they are not very positive answers because they haven't. They said that they haven't noticed any savings and any improvements. So, and they complained on some disturbance during the implementation. So, due to these results, our colleagues from Phoenix asked us if we can provide some information for this not so positive feedback. So, sorry? Sí, yeah. So we decided to ask to all technicians involved in the demo site their opinion about that, what they think about these results. They were the technicians from the construction company, from IREC, from PIC, from housing agency. So, but only 30% of these technicians have a direct feedback from the users. So the main things, the main conclusions, only to highlight is that the construction roads are always annoying from users, from people who are inside, and that there was not a lot of time to feel the improvements inside the dwellings, and that there was some adaptation that needs to be done during the project that Letian had explained, that increased some disturbance inside the dwellings. And we take advantage of this survey to these technicians involved in Terrassa demo site to ask what they think that we can do in a future project to improve results and to improve this feedback from users. So these are some of the answers we obtained from these technicians. So they propose to involve a social specialist or a company that is used to obtain more engagement about users. So include a construction work company for the very beginning, that perhaps it helps to take decisions or to evaluate risk together and not to find in a post steps of the project, and also add some new tasks or work packets, in order to have more information after the plural solutions implementation, to have so the users guidelines and maintain guidelines too, to include in the digital building passport, and also to try to increase the duration of a project in order to have more flexibility if there are some problems. So this is the main result.
Well, for me it's quite interesting, this approach. The engagement of all related stakeholders, I think that is a really strong information. I think that maybe, I didn't read about, maybe you should include this information for business plans in order to provide some info to potential investor or so on. Make this public. I don't know the way that is the best way to do that, but I think that it will be interesting to do that, but maybe for all demos, and I don't know if all demos have done this work or not.
You will listen.
Okay, well, but thanks a lot.
Okay, thank you. And there is no the
Yeah.
short video.
We try to put, I don't know if it's gonna work. No. This was the video that we had in the Gianni, we have internet here? Can I put the video in the, just to, let me see. Yes? We don't have it.
Via YouTube?
No, you can go to the plural file. It's not working here, I think.
Is a hyperlink here?
Yes.
Will it?
Can we try?
Yes, of course.
I don't know. Someone is. Wait, let me put. Let me see. Okay. Wait. Not working. Sorry. You can. Control F, no?
No,
F? Just F. Yes, you can open YouTube. I think it's better. Yeah. No, you can. We can open YouTube. Will be more. No. No? What I did? Okay, sorry. Now yes. So now, from our part, that's it. We open for questions or any comments about this. if you have already. Thank you, everyone.
First, an applause to all the team. You have done really hard and good collaborative work.
Thank you to Maria.
This information, please.
Okay.
No, well, it has been quite interesting. I think that you have done a very, very good work. and try to publish, try to put in, to address all the relevant stakeholders, technicians, final users, investors. Well, I think that you have worked really hard, and thank you very much for that.
It is just an idea that came to me just now. If we can put all these videos in our websites, in PA website, not the project. Yeah, that's what I mean. The PA website, the IREC, the TEC, the AHC website. So it will be a good promotion. Okay. Now let's move to the next demo site, going to the center of Europe, Kasava. Unfortunately, Katerina, who has been coordinating all the work, she's ill and she hasn't been able to come. But Jan has been supervising the work from the beginning of the project, and he will make the presentation together with Daniel.
So, hello to everybody. You probably noticed that I'm not Katarina, unfortunately. So she apologizes because she's really sick today, and she was sick from the Sunday, so she cannot join. However, what I want to emphasize at the beginning is that she was the person who put together all the partners, and a big thanks belongs to her, because now we have this nice building which is located in Kasava, Czech Republic. Without her support and without support of our partners, we wouldn't be really able to finish the renovation. And trust me that there were certain moments when I thought that we will basically give up, because there were that many complications, that many problems, that many delays that we need to face and that we need to overcome. And I'll be talking about them, don't worry. So, I think that if you take a look at this picture, we could be really proud of the building that was finally finished, and it's functional, operational, and running. And what I have to say from my personal opinion is that it's really actually nice from the exterior as well as from the interior. And according to the technological systems that are being integrated in the building, I think it's one of the really unique buildings in the Czech Republic. For example, we don't have any other building in the Czech Republic with even a similar heating system as was designed in this case. So let's jump a bit into the history of this whole project. And first of all, I will try to explain what were the objectives of this task. Obviously, what we want to do within this task was to install the Connex wall system or wall heating system for the Czech demonstration building in Kasava. And we wanted to identify and assess the technical viability of the whole system, which has been done in prefabrication in the company of our partners, RDR. And obviously, when the renovation is done, we want to do the monitoring and assess the energy performance of the whole system, which we didn't complete it because really the building was finished a month ago, and now we will give the support to the mayor of Kasava to continue the monitoring phase, because although for us it's very important to know how the system will perform in the future. The key outcomes are that we successfully finished the renovation of the Connex wall system. We performed the test of the technologies, and there are actually quite unique and innovative technologies that are not shown anywhere else in the Czech Republic, and it's including also the external wall heating system, which is combined with the heat pump. We have the integrated air handling units in the facade, and we were able to test all the technologies that are in, and they're working, and they are operational. And we want to, obviously, to validate the energy consumption, and we had done it using the simulation, and Daniel will be talking about it after my presentation. So, a brief recap. The convex wall system consists of the heating loops that are attached to the external surface of the original wall. That's a unique feature of the system, and it is really not very common. And at the beginning, I didn't trust to Daniel that it will be working. However, he tested it in the month of September, and it's working. So, and now I'm really glad, and he persuaded me that it's going to work. Apart from the heating system, which you can see here, we have air handling unit which is integrated in the facade just next to the window openings. It's possible that we would be able to integrate the photovoltaic panels, but for this specific demo, we decided to put the panels not on the facade, but on the roof in order to increase the overall harvest of the energy which is coming from the photovoltaic. And also the roof was much more better place to install due to the orientation which was really ideal in this case. Obviously, we also increased the insulation properties of the whole facade, and thus we were able to decrease the energy consumption to 1/4 of the original energy consumption of the non-renovated house. Here we have a short timeline how the renovation start. We started with the preparation works on the Kashava, which I will be talking about later on, but what I wanted to say in this slide, that we really finished the renovation at the very end of the project. You can see that in the last month of the project, we finalized all the works that were on the site. Now, where is Kashava? Kashava is middle of nowhere here in the east part of the Czech Republic. The building which was selected as a demonstration case was constructed in 1946 roughly to 1950. And if you would look at the material that was used for the construction, you will immediately find it out. Because it's not homogeneous construction. There is a lot of bricks, a lot of concrete prefab elements, but also some kind of hollow bricks. So we need to face this unhomogeneity in the original structure of the building. And basically, it was this ugly building in Kashava that we renovated. It consisted of 2 apartments, while the ground floor apartment was like quite good in size, but the other apartment under the roof was quite small. And that was the reason why the mayor and the owner of the building want to have an extensive renovation, also to increase the upper apartment to the full-size apartment. So we can see that the extensive renovation was to improve the overall quality of the building, and the floor plan layout had changed to increase the inhabited floor area. And as a result of that, we need to demolish some parts of the building that you will see on the next slides. One remark here, there were no inhabitants within the building during the renovation. So let's jump to the renovation phase. Original state, where we already started some groundworks here. We put down the roofing structure and also some walls of the older structure. Here we have the plant with green. In green, there are existing walls. But in the second story, you would see that there were walls that were demolished during the reconstruction. And for the reconstruction, we designed actually 3 types of the panels. The original panel, which was planned for as a plural solution, is type 1. It's here on the left side. It's wall type 1 panel, where you would see the original masonry wall in Kashava or anywhere else, then the heating layer, which is supplied by SPF, and then the additional facade layer consisting of the insulation and the cladding, outside cladding made in wood. The wall panel type 2 is not the original one, because for the parts where we demolished the original walls or there was no wall, we need to put the heating layer just below the plaster cladding on the interior side, and then again improve the whole isolation here. And the roofing panel you can see here on the right. Here we have the plans of the panels. So in the ground floor, mainly there are the panel type 1, that's the plural panel with original wall. But in the second floor, there are parts where we have the type 2 panel, for example here and on the sides here. And obviously, we have roof panel on the roofs. So preparatory works. There was a big delay in getting the building permit because everything then has to go to the public tender, and also due to the tendering, there was a certain delay in time of the starting of the reconstruction. We need to prepare the site. However, it was going quite smoothly. For the next time, we need to cope that the old buildings, they are not straight. There are some imperfection on the surface. Some walls are like bended, and I think that without 3D scanning, it wouldn't be even like possible to design the whole building. Even with 3D scanning, there were some imperfections that we need to sort out on the construction site during the panel installation, and I will show later on. Our partner of the project, RDR Rimařov, they produced the panels on the line, so you can see here the picture from the factory where the different layers of the panels are putting together, heating layer also, and then let's jump to the construction side. The panels were taken from the factory where they were prepared, and they were brought to the construction site, which was already prepared for the installation. The preparation means that we need to put the anchoring system for the whole panel structure on the side of the current building. You can see the anchors here. The anchors were specifically designed for this project, allowing us to press the panel towards the original wall and to achieve the good heat transmission between the heating layer to the current wall. So here we have the anchoring, and here the guys are already installing some panels. Yeah, if I consider the whole delay of all the separate processes, the final installation of the panel on the site was really very fast. It was within the 5 days. We got the completed whole building covered with the panels. So it was amazingly fast with respect to the delays that were created according to the tendering process and building permit, for example. So the panels were installed using the crane. Yeah, here you can see already installed panel. You can directly also see the heating loops here. Here you can see the anchors allowing us to compress and to press the panels towards the original wall, here with the screws. Here is the panel type 2, which goes on the side. And here also you can see that the loops are just below the plaster and the roofing panel here on the right. So finally we have the house. But it was in the period of November 2023, if I remember, and fortunately we were able to complete the house to cover it with the roof, but not with the final layer of the roofing. So it was protected against the water intake, but there were no windows at that time, and we were waiting for the windows, and we were waiting also to finish the whole facade and the whole roof. So when the building was finally closed, we start to work on the systems. So the heating pump was installed, and we also installed all the distributors for the hot water or heating water. And we also finally connected the photovoltaics and all the other parts of the system. And now you have the comparison, this ugly building originally, and now this very beautiful building in the current state. And what we achieved, if I would take the building energy labeling, which is valid in the Czech Republic as a standard process, we jump from the category G up to the category of A, which is what we wanted, because we will achieve NZEP in that way. And we reduced the overall energy consumption to 1/4 of the original one, which is an extremely big improvement. Here we have some pictures from the construction site, so there is still some rubbish around, but nowadays it's already cleaned up. And to sum up, Katarina told me that I should talk about the challenges that we were facing during the renovation process. So definitely there was large delay in building permit, as I said, which unfortunately postponed the whole renovation process and its start. So we ended up in the period when there are common rains and snow in the Czech Republic, which was not very good for the construction works. Also, what was really challenging was coordination of the partners, because they were working with the technology that was not common for them, and the innovative heating system was not something that RDR would do on a daily basis. So we had problems to get the correct materials, and also to explain the workers how to properly install the system on the construction line. So many thanks to Daniel and his team, because they were involved in this installation, and they visited RDR several times to have it done correctly and properly. Then, maybe what I would mention is that also we had problems with window installation, because windows were not integrated in the panel on the construction line. Then when the panels were installed, we received the frames and the glazing, but the glazing was broken, so it caused another delay in the installation and in closing the building. And these problems we need to face up again. And here we can see another problem, that even if the building was 3D scanned and the design model was quite accurate, when we compress all the panels, there were some gaps in between the original wall and the newly installed panel. And we need to sort this out on the construction site. So the only way how to sort it effectively was that we will keep this gap on the side where there is no heating layer. So on the, I think it's on the stairs, on the stair wall, there was a gap caused by the inaccuracies in the panel, because it's also hard to estimate how we will compress each individual panels. So, as I said, some adjustments or on-site adjustments were needed. It created some delays, but at the end of the day, it's important that the building is operational, and the good news is that starting from December, I think, there is first contract signed, and we will have first inhabitants in the building. The main deviations from the delivery of actions was the timeline. It was really, the building was finished in the last month of the project, so we didn't have much time to get the real monitoring data, which we will be able to get early next year probably. And we also didn't have much time to tune all the systems, which we will need to do even if the project is over. We need to support the Kašava mayor to have it running in optimum way. Daniel, floor is yours.
What do you think about the scalability of the solution? Because what you propose is that you need 1 to 3 years to optimize the solution in deliverables. Then I would like to know, what do you mean when you say optimize? This PV on the facade, which kind of things do you think that you need to improve or to optimize to jump into market?
Yeah, I think it's a good question, but it's quite clear that if also the manufacturers of the facade panel would have some previous experience how to do it, what materials to order, what materials they will need, it will be like much faster. So one part of the optimization definitely lies on the manufacturer side. The other optimization would be in the way how to install it. We did it first time, and I think that even in our second project, we would cope with the facts that are related to the compressed layers, for example. This is something which was new to us. We had rough estimates how it would be installed, but I think that the panels and also the anchoring system could be optimized and adjusted in a way that the next installation would be more smooth than ours. So that's another way of optimization.
And the operation phase as well.
Well, we didn't come to it so far, but definitely.
No, but I think that many participants in this demo made the things a bit difficult by reading deliverables. That windows go this side goes the walls, you can with something that is not well designed. I think that how do you imagine this solution in market? One only partner, 2 partners, how do you imagine it? Is your solution, or you have to keep a lot of different technicians working in the solution?
Well, I think one of the problems was that actually maybe there were too many different partners in the cooperating on one thing. I know that for the research project it's necessary and it's beneficial, but I can imagine that if the RDR would be willing to put this system on the market, they would need to get more things done on their own, to all the windows, to design the system, and to build like everything together in the factory.
and then really bring the whole panel on the side. In our case, it was not possible due to the delays that we were facing, but to really to integrate it in a way like we planned in the factory, it would save a lot of problems and it would save a lot of time.
Who will be the owner of this innovation? Who will be the owner? RDR will be the owner of
Well, RDR probably is the major owner of the system because they put the most of the technologies together on their factory. But definitely,
well, in principle, you have different ownerships, let's say, and we haven't protected any of the development, so in principle, it's open for public. But SPF, let's say, is owner of this heating layer idea with a compressible.
I asked this because I have to fulfill the innovation radar and who is the owner of each thing. What I can read here is there is the energy harvesting window. I don't know how do you plan to solve
the big
this?
developments are, I would say, the heating layer implemented in a prefabrication on the panel. That's on SPF side. Then there's a big work about the control system. This is done by CVUT.
But if we're talking about the Connex wall panel, then it's shared ownership of the IP, which is used in it.
RDR and SPF.
Yeah.
Everybody have the system.
It is not patented yet.
Yes.
It is an extension to pre-existing experience and knowledge of RDR. RDR already prefabricated wood facades, but without the heating system. The heating system has been developed by SPF, and the know-how belongs to SPF. SPF, as a university, has not proceeded yet, or is not tending to have a patent. So this is really a pity for this project because it stops now. If we had more time, we could have really gone one step further, developing the framework for a market uptake of this solution. And what Jan and Daniel described is actually what I also said in the beginning. The main problems are lack of efficient value chain. Jan explained this. RDR has to get the components and the materials from a big number of suppliers. If they want to go into the market with such a solution, they need to change their business model. They need to have a new approach of how to organize the production, I think.
Yeah,
so there is still a lot of work to be done in terms of bringing this type of solutions to an industrial production and large market penetrations. What we have shown in the project is that it can be done, despite all the difficulties that we have. But it can be done, it is efficient from all the aspects, but still there is need to work further.
Then you are a bit optimistic when you think about 1 to 3 years to jump into market.
Really, if we're talking about the mass market, as RDR does in the current situation, then it would definitely, to introduce this technology into their standard offer, it would really take 1-2 years, I can imagine.
But now it's a prototype.
Yes, it's in a prototype phase at the moment.
Tier L7 or 6?
Huh?
Tier L7 or 6?
Well, because it is already installed on the building, I would be saying 7 or 8.
7 or 8. What's the time? Oh no. I thought that doesn't work. Okay. We still have time, Maria?
We are already late. I don't know whether you want to stop, have lunch, because it was planned for 13:15, or you want to finish the presentation and then go for lunch. I think it's better to finish the presentation if you can endure the... Okay, thank you.
Okay. So as Jan said already, we had the situation that the installation was finished just by the end of the project, and we have not a year of monitoring in the post phase of the renovation. So we needed a new approach for the assessment, which was that we did test runs to check about the functionality, the principle of the convex wall. So we heated the facade. And with the gained measurement data, this was used then to validate the transit building model. And with this validated model, we did yearly energy simulations to gain, or to refresh, let's say, the KPI that were then simulated. So here on the graphic, you see, again, with the measurement data coming from the test runs, we got the information, is this technology working in Kashaba? Then from the measured data, we took, let's say, the ambient conditions for the building model, and then we simulated and got room temperature for each building, for each room. And this was then compared with the measured room temperatures for the several rooms, and by this we did a model validation. And we got, so to say, correct behavior of the building model. And then, again, we took the boundary conditions from the 7.2 and did yearly simulations, which then gave us the updated KPIs. So yeah, as already mentioned by Jan, we had some, there were some doubts when renovating the building with his work afterwards, with his heating. So what we see here is a cross-section of the southern facade at the window opening, modeled where, or we assumed we have solid clay bricks, but in reality we had quite a inhomogeneous mixture of hollow bricks, air gaps, wood wool, lightweight boards, so it was a bit a mess when opening the walls. But that's reality is. So there were doubts regarding the model. Did we assume correct thermal conductivity or heat capacity and so on? These were a bit the screws where we could work with during the validation of the model. And there was also, here it's a view from above, the question is the thermal contact of the heating layer to the old wall good enough to heat the building? Then we did the proof of concept, let's say. Here in the picture you see it's over 3 days roughly. We heated up the building, starting flow temperature 39 degrees to, so in the heating layer, to 48. So we overheated, let's say. In the blue lines you see the return temperatures, so the delta T we got there. And here in black is the power of the different loops. So we have 3 supply lines in the building. The result is, so the room temperature, and it was September, end of September, we started at around 16 degrees and could heat the rooms up to 22 to 26 degrees. So it was good to see that the heating can be, the building can be heated with the layer, with a convex wall.
With this, what you are testing is that the system works.
Yes.
Mainly.
Yeah.
Only that the wall one, the one that has this brick mass works. This is what you are trying, or you are trying to the second typology that has not this inertial mass. This is my question.
Sorry, I didn't get the question.
You have two kinds of wall. The old one that you have added, the system, and the new one that you have changed the whole approach, and you have included directly the plaster, and after that the heating system. Yeah. Then, what are you testing with this? The old one or the two of them?
Actually, we are testing both, so you can hardly see it, but so the EWH is the external wall heating, and the IWH is the internal wall heating. So we heated the whole building, all rooms. So all was tested. With the interior heating layer, we have no doubts that it works. The main question is whether we can heat through the old facade, the existing one.
When you are testing everything, is quite difficult to know which one of the two system works better. I suppose that the old one that has a thermal mass that works properly, but
it works slower than. But here you see all rooms of the building, so there are rooms included here with the internal wall heating. So in principle, they work.
Yes. You are using an only thermal zone, and only or
No.
more? No.
Each room is one
Each room?
thermal zone.
Okay.
Yeah.
And some rooms have one kind of wall, and some other have other kind. Then my question is more related to that. If you see differences between one system and the other system, because one of them is clearly related to retrofitting, and the other is for new buildings.
Yeah.
Okay.
Actually, do we see? No. Well, we just did a general view that this is working. We can heat the building, and anyway, we look at only one dynamic to just bring heat in, not stopping the heating and see what the room temperatures are doing. This couldn't be tested until now. It was a very simple test, just heat all rooms, and in principle we got the answer. At least we can heat the building. Which is a good answer after having.
Well, I suggest to continue with this kind of test, the differences between not out of the project, but I think that it will be quite interesting to
Jan
test.
already said CVOT can follow next winter, and I got also, so with from our institute we have also a tiny budget, let's say, post plural, where we can follow the system in the first winter, which is very interesting and helpful also for us.
I just add that each room is equipped with the indoor air quality monitoring, also monitors the temperature, so the control system is connected to these sensors, and there could be only the feedback loop control, very simple one, to adjust the differences between the old system with the large capacity with respect to the new one when there is a very, very small capacity of the system. So we cope with that, and by using the separate loops, we can modify the power which is going to each room.
So, before this was just testing and measurement data. Now it's shortly about validation. So as I said already, we took the boundary conditions to the building model, like ambient temperature and thermal power of the heating distribution, so in the transient model. And then we compared the measured room temperature, so for each room, the measured temperature of the room and the simulated temperature by such a delta. So we took the difference, and then the validation aim was minimizing this delta, or like shown in the equation, so it was a normalized root mean square error, which was minimized for for most of the buildings, or for all of the rooms. What we changed is mentioned here. So thermal capacity was a topic, thermal conductivity, and also wall thicknesses that we had to change a bit. And all these changes were done in a physically meaningful manner. So in a range where we could say, okay, that fits. Now we have more cement in, so let's increase a bit the thermal conductivity and so on. So this was done during the validation, and so you see quite a large effect. This is an example for 2 rooms. Again, these 3 days of the testing. In black is the room temperature now here for the bathroom and the ground floor. And before the validation, we had simulated the room temperature here, so there was quite a big difference. Same for the other room shown here, a sleeping room. And after the validation, we have quite a good match between the simulation and the measurement. Again, the validation I mentioned, we used the root mean square error. Here for all the different rooms shown, and there was a second floor, the room in the south, sleeping room in the south. There we have a higher deviation. But for the rest of the room, we are below 15%, which is quite satisfactory. Then, after the validation, we did the yearly energy simulations again with the boundary conditions of the D7.2. Now we use the normal or the planned normal heating curve, maximum temperature of 35 degrees to have a good efficiency of the heat pump. And when comparing then the results before and after validation, we have a slightly lower space heating demand of 5%, and then related to this also electricity demand for the heat pump. For sure, there were no differences in domestic hot water demand and PV productions because there wasn't a change, and we can show no change for this PV self-consumption because the effects on the heating system are quite low regarding to the simulations over 1 year. Regarding the thermal comfort, this is one typical plot where you see in colors the different seasons, so winter, up summer, spring, and autumn. And in blue, you see that in wintertime we meet quite well or very well the comfort in the rooms. In summer, we might have like a slight overheating, but here we didn't focus on because we're in Czech Republic. Winter is important. Maybe with different behavior of the real inhabitants, like shading of the windows, they will have a better comfort in summer. That might be not an issue. What we haven't simulated or implemented was cooling with the convex wall, which is in principle possible, but not looked at in Plura. So could be done maybe in future. And again, with the summer simulation, we are not so well. Maybe shading or ventilation is not modeled to act too well. We didn't change the control for the summer behavior, so that might be a bit off with the results. But they are not important. The winter counts for cassava. And also the predicted mean vote we have used. You can see it again. Summer we are a bit out of the aims, but in winter time. So the negative values, they are in a good range. So we can assume, well, it's again, we have not measured, no inhabitants in, but I think we can quite rely on the simulations, and they show we are in a good range with the comfort. Just to show these KPIs, don't go through them now, but they are in the report. Again, in blue, the ones we just had to simulate, because the energy-related ones. And then, well, summing up.
Sorry, for the KPIs, did you calculate everything? Because they are not included in the deliverable 7.6.
The tables are included.
Here, you have a comparison between smart wall and envelopes only.
In 7.6, no, we have already...
In 7.6, we can check. I check.
Definitely, they are included. We can, yeah. Okay, just to sum up again, so the status now, or the view from now, is that the convex wall was successfully installed and the building system is commissioned. That's definitely done. We also developed, or CBOT developed, the control system for the entire building technology. So heating system included PV and ventilation, all is controlled by a central control system. Then the test runs, as shown, they give a good hint that the convex wall works well and the building can be heated. And the energy performance and the comfort of the demo building could be significantly be improved, which is not shown here directly, but before we had also CO2 concentrations of about 6,000 ppm in the sleeping rooms during night. And regarding to the simulations or also experience from the ventilation experts, we will be below 1,000 in reality. All these decentral ventilation units, they are controlled via the CO2 concentration. So it's clear that the inhabitants will have about much better air quality in future. And then last point, the energy-related KPIs, as shown or said, are gained by means of simulation based on a validated model. That's all in a short version.
Well, again, that the same thing that for Terrassa. I think that you did a really good work. And it has been really difficult with so many partners involved and so many problems. So thanks a lot for your work.
Thanks.
Please, I would like to ask all of you to come to take the official photo of the plural end.
Oh, yeah.
Αυτή. Α, δεν ξέρω, ναι.
Κάτσε μπροστά σε ψήλωση.
the work package 7 with the third demo site, the Greek demo site, which we will also visit tomorrow morning. And Mr. Tsoutis is going to start the presentation today, and tomorrow he's also going to explain to us the technological advancements achieved in the demo site in Greece.
Well, I will try to be as brief as I can, because obviously tomorrow we are going to visit the site, and mainly because 7.4 has been already presented in the previous reporting period. I would like, though, to have to put back in your mind a small roadmap on how we built up all this project in Vula. And starting with the design, which it was a big challenge because we had to replicate exactly the facades as they were in the original conditions because of the restrictions that they imply on the Greek regulations regarding the building permit that we achieved. So we finished the design, and we identified the exact locations where smart wall needed to be installed. And we also installed two different pieces there, one external and one interior piece of smart wall in specific locations according the simulations that we produced on the design stage. On the installation, we had several systems installed on the building. We had the PV panel system. We installed the domestic hot water system. Also the heating and cooling system with the pipe wiring and the heat pumps. And obviously we needed to do some METIX installation on the back side of the building because it was not able to install any smart wall in this area. We installed the balcony doors and the windows. That was a very challenging task, and it was a very difficult task. And I will explain you later on why it was. And smart wall, the anchoring system, which also was a challenging task, again, for the reasons that I will explain later on, both for the interior and the exterior side of the smart wall units. Finally, we installed the smart wall in the exterior and the smart wall in the interior. First of all, we met a lot of challenges, as I have extensively described in the previous reporting period. The hygiene issues that we faced during construction because of the pigeon nesting on the building, the deterioration of the services that they were in the building, and the most important were the cavity walls condition, where they are almost deteriorated, at least when the windows and the balcony doors have been removed. First of all, the cavity walls, you can see on the left side bottom picture that there is not even a wall in this area, and that led us that we had to produce some metal frames in order to support the cavity walls. That was have been done according the instructions of the technical department of the municipality of Voulavare Vouliagmeni. Then we had to modify all smart wall panels that needed to be installed in these specific areas. And finally, we have to do extensive repairs on these cavity walls that seem to have the problem. And you can see how the building was prior to the installation of any plural system and how it was after the installation. Obviously, you will see it with your eyes tomorrow morning, and you will have a better opinion about it. You can see also the exterior of the building and the interior of the building after the installation of the plural systems. Jordi in 7.6 has described very thoroughly the monitoring campaign in Voulavare Vouliagmeni demo site. I will stand up on the point that we have split the two apartments in 9 thermal zones and 9 comfort zones. And what was important for us to understand is how the existing heaters that they used during the winter were having an impact to the actual energy performance of the building and the energy consumption of the building. The monitoring started on the 27th of September 2021, and it was completed on the 30th of July of
2024, sorry, that's a mistake, it's 24, not 23, of a duration of 34 months. All the data have been monitored via the AM scope, the HAMS analysis platform, as well as with the sensors of NTUA, and they were online for all this period of time. The overall consumption of the plural of the building, as you can see on this slide, which it was intensively written on this page, because we needed to identify the winter periods and why it was this increased consumption during this period. After the analysis of it, we found out that the A2 apartment, the overall consumption was 15,950 kilowatts. The average daily consumption was 22.65 kilowatts. During winter, it was 32.5 kilowatts, and during summer, it was 11.21. And for the A2 apartment, was a little bit less because there is one room less on A2 apartment. It was approximately 14,000 kilowatts. The average daily consumption 20.93 kilowatts. The average winter consumption was 25 kilowatts and 14.96 during the summer. If we want to analyze it a little bit more, because we enter in a condition that we were able to measure all the devices that they have been used during this period, we found out that the portable heaters were representing the 24.45% of the overall energy consumption, and during winter time, when the heaters were operating, were corresponding to the 46.68% of the overall consumption. The electric boiler seems to be quite high, which was 7.35% of the overall consumption, while all the other appliances were less than 9 kilowatt hours per day. In A2 apartment, similar values with the overall consumption of the heaters approximately to 26.22%, and representing to the 49.98% when during the winter period. The electrical boiler the consumption was a little bit higher than apartment A1 to 9.68, and also the appliances were a little bit higher to 10.15%. When I'm saying the other appliances, is these appliances that we could not measure, and it was like the fridge, the oven, like the washing machine, the lighting, the plugs. If we want to analyze the post-plural installation, we will find out that 96 days of almost a year, this apartment was not habitable, and it was rather difficult to identify to extract accurate data and accurate values for these days of the monitoring period. The overall consumption during this post-plural installation for the 365 days minus 96 days, which was not habitable, was 4,442 kilowatts per hour, and the average daily consumption was 12.22 kilowatts. Analyzing also the data that we had from the sources of energy consumption, we found out that the building was normally occupied 178 days, and that appears to be an increase of 38.41% during the plural installation. But this is something that we expected, because we had the heat pump, which it was cooling and heating the building all over the time, the period of 365 days, while previously we had only the heaters where they were heating the apartment only for 95 days. And the most important is that smart wall systems were corresponding to less than 8% of the overall increase of this energy consumption appeared in apartment A1. For the apartment A2, it's more clear the things that we find out. We can identify very clearly the autumn and the spring period, where the heating and cooling, it was not necessary this period because the temperature was good enough for the cohabitants. And the overall consumption was 6,802 kilowatts, and while the average daily consumption was 18.64 kilowatts. Now, similarly, we found out that the boiler consumption, which was, if you remember, I said before that it was less than almost 8% of the overall consumption, has been reduced to 0.18 kilowatts instead of 2.3 kilowatts. And this is mainly because of the use of the domestic hot water and the solar panels that were installed in the roof. The use of heaters has been almost eliminated, and the average consumption of the heat pump was 9.6 kilowatts per day. The smart wall systems are low consumption appliances corresponding to approximately 0.6 kilowatts per day, and the average consumption of the non-measured appliances remained the same, reduced to 8.26 kilowatts instead of 10.15 kilowatts because of the elimination of the portable cooling device that they were used during summer 2023. Comparing these periods now, the post-plural and the pre-plural installation, we found out that the consumption pattern remains stable with daily values between 11.2 and 16.9 kilowatts, both winter and summer period. During the pre-plural installation, the consumption peaks were 14 to 28.6 kilowatts, and they were also observed both in summer periods and winter period, mainly because of the use of the heaters and the cooling devices that they were used in apartment A2. During the spring and autumn period where no cooling device, the average value was observed was about 10.28 to 16.7 kilowatts as a result of the solar panels that they were used and the elimination of the electric boiler. Finally, the overall reduction of energy consumption was 11.5% after the plural installation, and you have to keep in mind that during this period we were cooling and heating the building 365 days, and the operation of the pump was constant, apart the autumn and the spring periods. Any questions? Because Yannis is going to.
During the post-plural installation, have you been using the whole time your smart control system?
Yes.
Yes.
The data that were observed, they were coming out of this.
Then this overall reduction is related. How much of this result do you think that is related to the smart system, to the control system?
All of it.
All of them.
All of them.
All of them for all the energy consumption system.
Yes. And keep in mind, keep in mind that also we have a building which it was heated and cooled 365 days instead of 90 days that it was only heated during the pre-plural period. And this is the important thing. Even that we had the consumption for 365 days, again we achieved a reduction of 11%, even when it was heated and cooled all the time of the year. This is a very, very good result for us, and unexpected result, to be honest with you.
I can't have the global approach. I have seen each installation, but this is the whole approach.
For the overall approach. Yes, it's clear. The red line is the pre-plural installation, and the blue line is the post-plural installation. And you can see when we have the heaters, how it was operating, how it was functioning according to the energy consumption.
Following the thermal comfort assessment approach that has already been described from Jordi Masia, here we have measured the most accurate indicator that predict the thermal comfort inside a room, the PMV, the predicted mean value, that is an index that predicts how an occupant feels in a conditional thermal environment. So if the PMV is +3 is a hot environment, -3 is a cold environment, while the most thermal comfort condition is when the PMV value is at 0. So in order to calculate or to measure this PMV value, all these needed inputs are required. So in the frame of the Plural project and the other European project, NTUA has developed the NTUA multi-sensors that measure all needed input in order to calculate the PMV value. The radiant temperature by this one, the air velocity by this one, the relative humidity here, and the air temperature here. The clothing factor is assumed from ISO standards, while also for metabolic rate we assume ISO also.
How many net have you used?
How many?
Clothes.
Yes. We have this profile when when it is winter, January until March, the clothing is up to 0.85. When we have spring, 0.7, 0.60 at, yes, it's a profile. It's a dynamic profile for clothing factor. So we have installed this multi-sensor at several spaces inside the two apartments. 9 in total multi-sensors have already installed. Here there are the results for A2 apartment that is the more representative apartment of this building because this apartment is occupied during the whole measuring period. Here you can see the results regarding the summer period. As you can see here, before plural renovation, the PMV value was above the limits. That means that the occupants feel warm or even if hot, like here, at the different rooms. This is due to the fact that there is no any cooling system installed at this apartment. However, when we installed the smart wall and the plural renovation processes, the PMV values are inside the PMV limits, that it is minus 0.7 to plus 0.7. That means it's the category C, the limits for the category C. So we have improved thermal comfort conditions after the renovation. In the graph here, you can see the outdoor temperature from the weather station, the indoor temperature from one indicative room. Here is the bedroom of the A2 apartment, while the PMV value here, the hourly data, that are measured for the two different periods, two different Julys, for July 2022 before the plural renovation and July 2023 after the plural renovation. Here are indicative results for the winter period. During the winter, the apartments are heated in both cases. In the one case, before plural renovation, the apartments are heated by means of electrical heaters, while at the winter period after the plural renovation, we have the heat pump and the smart wall application. In two cases, at the two states, we have acceptable PMV values that are within the limits of category C of thermal comfort. That means that the PMV value lies between minus 0.7 to plus 0.7. And of course, the temperature, as you can see, are in comfort conditions. Here is a graph, several graphs for the comparison of different rooms of A2 apartment for the two states before and after the renovation. We have at each point, the color of each point indicates the PMV value. When it is blue, it is cold. When it's red, it's hot. And when it is green, it is inside the comfort conditions. And the graph also shows the relative humidity and the temperature value. As you can see, for example, in this room, the bedroom 1, the temperature lies from 18 degrees of Celsius at the winter months, while at the winter months, the lowest temperature is about 23 degrees of Celsius for this room. The same results can indicate for the other rooms, like a living room or in the kitchen. Of course, in kitchen we have several gains due to cook oven, etc. So for this reason, we have increased temperature up to 34 degrees of Celsius before the renovation. But after the renovation, when also we have cooling system, there is not so warm temperature, and the temperature lies below 30 degrees of Celsius. Overall, here are the results regarding the improvement of the thermal comfort condition due to the application of smart wall. Before plural renovation, we are conditioned up to 70%, while after plural renovation we have 9% improvement, while 79% of the whole time are inside the category C limits. The same for the category B and category A. That's the most strict category, that almost 23% of the total measuring period, the thermal comfort condition was very, very good. So.
Prior to the plural solution installation, we had some interviews and we had some discussions with the owners and also the end users. Obviously, they were not in the position to let us know exactly what, because they haven't understood it, and it was rather difficult for them because of their age and because of their status to understand what it's going to do. They always had the fear that something will change their condition in the building. And finally, we delivered to them 2 questionnaires in order to reply us anonymously what it was happening after the renovation, and the words that we have, as you can see, I have extracted exactly from the questionnaires as they wrote it. They were very positive to us. They were very satisfied and that everything went smoothly. So apart the problem that we had in apartment A2 when we discovered the cavity walls condition, I suppose that they were satisfied. During this period, they were not satisfied because they had to stay to almost 15 days without windows. But in any case, in general, they were satisfied. Also, the municipality was satisfied with what we have done and how it has been progressed. We had no deviations from the actual door. Oh, sorry. Yes.
Well, I think that it's quite difficult to assess the user satisfaction with only 2. I think that is a pity, really. What I would suggest, if you can do it, is do the same thing that have done the Terrassa team, that they have tried to have the approach from all the engaged stakeholders, from technicians to the municipality.
We did the installation, we did the fabrication, my company did all this, so
then
it's rather difficult.
Well, but in Terrassa also they are involved in the assessment.
We can do it.
They have provided also their opinion.
This is not a problem.
I think that it will be useful to jump into market.
Honestly.
I have found this kind of problems. I have solved it this way. These kind of things, I think that if I was an investor, I will be really happy to know
about.
Okay,
I will engage my company, the guys, the technicians that work in the company. I will also engage the technical municipality, the technical department of the municipality, and we can reproduce all this.
Then I think that it will be more useful to reach conclusions that these 2 questionnaires that are a bit, well,
no objection.
You did your work, but...
no objection at all. As I said, no deviations from the actual door, and we had some risks that occur apart the technical problems that identified during installation as I described it, and also today and in the previous reporting period. And we found out that the apartment A1, which was not habitable for 96 days, really was a bottleneck and influenced all the obtained monitor data, and we cannot get real results from it. The KPIs, we have achieved all the energy and comfort KPIs. And that's it. Any questions? I will be happy to answer.
Yes. Look, if we go to your final products here, for the smart wall pool system, you are thinking about 3 to 5 years to jump into market. Why?
Because we need to establish production lines capable, as company, we need to establish production lines capable in order to accommodate and in order to produce it. Now think that we are a small company and we are not able to produce mass production. It was rather difficult for us. We need bigger spaces, we need a bigger area, we need new machinery in order to put it in the production line. But if we are able to have a deal and an agreement with a bigger company in order to produce it, we would be very happy in order to do it. But we have a plan of expansion between 3 to 5 years in order to increase our production line, to increase the capacity of our premises in order to do it, to put it in the market.
But here you have some more pieces. You have nano coatings on
Yes.
one side.
Yes.
You have the smart control system.
Yes.
And you have a 3D printing.
Correct.
Then.
Correct, yes.
I think that is a bit pessimistic, 3-5 years for everything. That you are going to be penalized for that because you have some pieces that you can sell directly. I think that as innovation, the assessment for nano coating 3-5 years is too high, and it's not in line with the idea of a successful demo.
There is an explanation about that. You need high capital, investment of high capital in order to go in a mass production, especially for the nano coatings, because we have to buy equipment which are very expensive, and doing business in Greece is not that easy, you know.
Maybe, but if you have TRL8, I think that doesn't match properly with 3-5 years. Then we have to change the assessment. We can't keep 7 and 3-5 years. Okay. You know, because I understand what you say, that you need money, you need investment for production. But as the Commission is going to assess the innovation degree, I think that it will be useful to go higher for this TRL, or to reduce. Yes, but they have also 7. The idea is I have to assess the innovation.
All right.
Okay?
Yes.
If I write that you need 3 to 5 years to achieve this innovation, to put in market, it's not really the innovation that they are expecting. Is that I'm trying to explain you.
Okay, I will give you a hint because normally I can't give it. Normally I can't give it, but I will give you a hint. We are already in a discussion with a big company in order to get to familiarize with the smart wall in order to probably in 2 years' time to be in the market. But this is something that we are in discussions. We are not concluded yet. We have not finished it. But if you want for us to write down that in 2 years we will be in the market, yes, we can write it down. But this will be a doubt that in 2 years will be in the market.
But if it depends on money, on the investor, it can be 3, 5, 10. When you have the money, you
Exactly.
produce. No, but the innovation is one other thing. The innovation is that you have developed something that maybe you now cannot develop a mass production.
Correct.
But you can develop a small production.
Yes, that's correct.
Then, in this case, you have achieved the innovation.
This is true. This we can do because we have already produced 34 panels for Vula. It's not a small number, 34 smart walls. It's quite big. It's a quite big number. So yes, this is true.
So we should change from 3 to 5 years to 1 to 3, more or less.
Okay, this is not a problem.
And keep the TRL length.
Okay, fine. This is not a problem. Small production, we are able to do it, but not mass production.
I'm trying to help you because the assessment requires that you achieve the innovation. Okay.
Thank you.
Okay. Well, with this we have finalized work package 7. Well, okay, for work package 7, deliverable 7.6. Everybody has took part in this deliverable. The three teams that are related to the demo, all of you have taken part in this. For me, this deliverable that is a public one is a bit confusing, especially for those parts related to KPIs. This chapter, well, we can discuss after where can we place all the public information that you want translate to the different stakeholders. From my point of view, this deliverable that is technical feasibility could be one of the right places to put all the information that we are commenting now, try to rearrange this deliverable. I see 2 deliverables after we discussed for work package 8, deliverable 8.2. That is the other public deliverable related to market access and jumping to market. Then, if you want, we can discuss after. Anyway, for me, this deliverable is not easy to understand. Well, we can go.
Yeah,
If I want decide about one of these 3 products, I will read this deliverable, and this deliverable is not easy to read. Maybe because everybody has worked inside, and then I think that has quite different parts. But we can decide. We can keep. I will try to change here, because here you have TRL, you have KPIs, you have pre-tech mean vote, you have monitoring, you have final results for each demo. Then,
one of the problems that we had was that we didn't have a separate deliverable for the monitoring results. Yes. So this deliverable was covering 2 tasks. And the idea behind the structure of this deliverable was to put together from a scientific point of view the findings and to make the preparatory work for the answers to the call requirements. That's why it is structured like this. We didn't think of preparing a deliverable that goes to the manufacturer or to the one that wants to invest from the technical point of view, to uptake one of the three technologies. Maybe this can go in the work package 8 deliverables, in the business models. Because somewhere, I mean, if we reduce the size of this 7.6, for instance, to make it more readable for someone that wants to decide, we will lose all the information about the monitoring results, which is very important. And also, we will lose the information about the KPIs.
Then I think that you should include a summary for each part, a monitoring summary, a KPIs summary, a demo summary.
Okay.
Just a table.
Yeah, okay. This we can do.
In case that I try to...
Yes, we are discussing...
To have a look,
it was very nice if you could tell us how you would expect to see this deliverable. I tried to explain what was in our mind when...
I understand. You have to put everything inside and then it gets...
Because we have also to answer the comply with the official requirements.
114 pages is,
Yeah,
if I am
but
the investor...
No, yeah, I understand, but there was an annex also. The annex was quite big. Okay, so what we can add a summary for each section and for each PNU. This can be done based on the presentations.
On the presentations.
On the presents.
Yes, well, we know.
Even your first presentation this morning, where you have summarized everything, can be useful.
Yeah, okay.
For this.
Okay, thank you. Okay, thank you.
Well,
Thank you.
It's very difficult to... Okay, so now we move to the more horizontal work packages that deal with the overall assessment of first of all, the environmental aspects and the market-oriented aspects. The work package leader is ITEC, and Diana Romeo was the work package leader during the course of the project. Unfortunately, Diana cannot be here with us, and Sebastian Christen is going to make the presentation on behalf of ITEC, and Petra Colantonio from Phoenix is going to present the business model and the business-oriented exploitation.
Okay, thank you, Maria. So here we have the review meeting for this last period. To remind everyone of the objectives of this work package, we have the techno-economic, environmental and social acceptance assessment for the kits. We have provided support on the revision of the LCA standard. We have an evaluation of the market potential and product opportunities, business models and business case for plural solutions, and the development of the exploitation plan and IPR strategy. So, of the 5 tasks of the work package 8, task 8.3 was completed in a previous period. And 8.1, 8.2, 8.4, and 8.5 were ongoing during this period. Just to remark here, 8.4 was extended up to month 48. So this is a Gantt for this period. here we have the 4 tasks that were ongoing. And as we can see, there are 5 of the 9 deliverables here on this period. So 4 tasks 8.1. There were it was divided in subtasks and deliverable 8.1 and 8.2. So as an achievement here, we can see we have achieved an analysis of LCA, LCC of the 101 configurations for the 3 kits. We have taken into account a series of phases of the LCA assessment for the product, transport to site, construction, maintenance, substitution, deconstruction, and transport to the waste facility. So here we can see in the LCA that for this project, it was the most impactful phase was A3 for the production of the panels. That makes sense because the construction is much less involved than in traditional construction. But also for the LCC, that the A4 is quite large. This is due to the large distances between the site and the factories. So we have also evaluated indicators that have been designed according to the European and national standards and submitted the deliverable on time for month 42. Also for another task, the standardization of the certification activities, divided in subtasks 8.2.1 and 8.2.2 that were both completed. We have identified and tested the certification of the innovation materials. We have developed a certification strategy for the deliverable 1.3, task 1.3, for CE markings and EPDs, environmental product declarations. Here we can see that we have provided a detailed guide about these 3 processes, the EAD, ETA, and CE markings. We were not able to provide a real execution of the guide, but it's quite thorough and up to regulation. So for achievements regarding the EPD, it's in accordance to the ISO 14025 and 1500804. We have done an analysis of the certification process and adapted it to the plural PNU kits. And simulated the EPD process for a smart wall PNU kit. Moving on to the standardization actions that we took. Here we have an analysis of the current standard for the BIM that for now it doesn't have much more information other than the 3D dimensions and stuff. But we hope to, in the future, to see the layers involved in products and also the sustainability impacts, physical properties, and things like that. We have the technical results of the support in the revision of the LCA standard in deliverable 8.3. And here we can see more about the methodology. I don't know if I can point with this. Yeah, so this methodology is based on this system here. It's already in place for construction projects in general, because when you are developing a project, you have to comply with your context, your city, here in this branch. And also you have to take into account the materials, the elements, the space configuration, and the systems in play in the project. So this is not the case for digital spaces. Like you obviously have it on paper, but for the digitalization of data, it's not quite there yet. So
I think that this is the result for deliverable 8.3. Is the matrix, is the digital standard that you have the matrix with the scale and the faces.
Yeah.
Well, I think that is really interesting. I love the ETEC LCA methodology.
Thank you.
And I think that you should highlight some way this, even by comparison with the other standards that are unuseful for the scale of material or unuseful for the scale of space. I think that, I don't know how, but you should highlight this work that is quite interesting.
Okay, thank you. Yes, so to that point, we have developed this table here that takes into account the 5 stages of a project. That would be idea, design, construction, operation, and end of life. And then distributed in this axis for these points of the structure. So material, element, space, system, and the whole project. And we have compared the ontologies and regulations that were provided for the project and assigned them like a value, like you see here, red, yellow, green, like how well does it respond to that phase on the life cycle and the scale that we are talking about. So in the deliverable for all those ontologies and regulations, we have a matrix of how well it responds to each of those. Okay. And now.
Can I just add something before we continue? In the frame of the project, we produced handbooks, training handbooks, and we have included the LCA methodologies as one of handbooks that it is free to be downloaded from the website by any stakeholder that it is interested.
I think that is quite interesting, but you have to make the whole training path to arrive to the handbook that are in the end of the are the 3 last documents, reports. Then I think that if it will be maybe it's going to be easier to understand after the whole training. But even without the training, I think that it could be useful to put in the website these handbooks for the downloading.
We could put it under the section where we have all the materials produced to download, to see, and so on. Mm-hmm. Okay, so task 8.4 was basically a summary of the whole plural technology. The deliverable 8.6, which is the outcome of these tasks, provides the overview of environmental cost, social impact assessment, the adoption of the kits, industrialization of the systems, and business analysis. It is very important at the beginning to highlight that the plural is off-site prefabrication, which was never done before. And so for the purpose of the business analysis, the so-called comparison study was done for the off-site prefabrication versus the on-site fabrication. It is also important to highlight that the business model includes a lot of assumptions, mainly because it was never done before. And the figures that you can see in the table below can be further improved with the industrialization of the plural exploitable results. For the purpose of the analysis itself, also the risk assessment was performed, very similar to the methodology for the risk assessment under the exploitation part, mainly related to the technical risks, legal, normative, as well as economic and some other aspects related to the business. As for the exploitation itself, there were 3 exploitable workshops performed over the duration of the project, and the last one was managed during the last General Assembly. Based on the outcomes of this workshop, the key exploitable results were finalized and also were reflected in the last update of the innovation radar. As you can see, and Maria also said in her general presentation, we have 14 key exploitable results after the project. Those which are highlighted in the bold are those which are included in the innovation radar. Then there are 2 reduced energy behavior models and best practices handbooks, so the 11 and 4th. These were not part of the innovation radar but can be downloaded and publicly available on the project website. I would like also to highlight that the result 1 and I think 4 had already some patents in place prior to the plural renovation, and as was discussed early today, there were some patents in plan. Each exploitable result after the, yes.
Could you go back to the previous table? Could you explain the meaning of those partners that are involved in the innovation but are not the owner, how they are related, the user with the owner of the innovation? Patents, because I didn't read the...
Okay. There is always the lead of the exploitable results, then there are involved partners. Each exploitable result is characterized. I will speak about details on the other slide. And then for each result, the IP protection is proposed. I don't know if I understood very well your question.
When you go to the commission format, they speak about forest SMEs that are responsible for innovation, but no IPR, any kind of patent. I don't know. This part of the technical report lacks sufficient information about which exploitation, which kind of IPR protection. And on the other hand, how the consortium manages if there is more than an owner or
the joint ownership is discussed during the workshops, the exploitation workshops. We as a Phoenix, as a leader of this task, we are just advising what should be done, how it can be done, because we are not lawyers, we are not the legal persons. But it is important that we evaluate in the characterization table who is the main owner, who are the participants, and there should be some common agreement between them how the ownership will be taken place after the project ends. So every result is characterized.
Petra, can I just, regarding the 2 exploitable results, that there was a previous patent, they have only one owner, and this patent belongs to the owner. So there is not an IPR or competition issue there.
Yes, but you have 12 of 14 exploitable results. Some of them are services, but some of them are products. Those products, how you solve? This is my question.
This is what Petra said. We have a major owner who is responsible for the marketing, the IPR, and for the further promotion of the product. And then it's his responsibility to make the agreement with the secondary partners that contributed to the development. Yes, because at the moment, as you know,
in the exploitation plan, we define for each result what are the planned things and activities and actions after the project ends. And then it is based on the lead partners and the involved partners, how they manage and maintain. Because, of course, the exploitation is an obligation after the project, that after, 4 years, the results needs to be exploited. So it's up to them.
But, well, in order to have a clear approach from my side, this go-to-market strategy occurred before you provided deliverable 1.7. It's already included in this deliverable, in the go-to-market strategy for each product. It's after the workshop that you developed, maybe month 37 or something similar.
Well, there were 3 workshops done.
Yes, but
the last one during the General Assembly, so in summer, I believe.
The last exploitation workshop is previous, or it has occurred after month 42? This is my question. Before 37.
During the General Assembly.
37. So results are already included in deliverable 1.7.
1.7.
Yes,
the go-to-market strategy.
Go-to-market strategy. Yes. So changes about are in 8.6. This is my question. The final solution is 8.6, but with not added agreement between partners. It's only you are summarizing there the results. It's like this. Okay.
So each result was characterized in detail. It was described, the ownership was described, type of level and level of the innovation, how it will be exploited, the unique selling point, the market assessment for the competitors, benefits, barriers, the TRL evaluation, which was discussed during each workshop and updated regularly, with the commercialization plan towards the TRL 9 for those which doesn't reach. And of course the IB protection, which is an important part of this. For the exploitation also the risk assessment was done, a very similar approach and methodology like the one for business analysis, for business case. And also reflecting not only what is required by the Innovation Radar and European Commission, but also reflect the market, for example, the coronavirus pandemic and so on. And I believe that's all from my side for now.
About Telegram, you have one public that is 8.2.
Yes.
And one confidential
8.6.
8.6. However, I think that some of the results that are included in 8.6 could be shifted to 8.2. For instance, I wrote here. Wait a minute. Well,
what we were also discussing is a possibility that on the website we publish the public summary of also those confidential confidential deliverables.
Yes, for instance, in 8Cs, you have the summary of LCA, LCC, and the conclusions. That, I think that will be better placed in 8.2, that is for public. Also, I have a minor comment about A2 that I don't know why page 12 you wrote that is confidential. I suppose that is.
It's a mistake, most probably.
To remove this
Sure.
this comment. For A2, I am a bit confused about the Excel sheet that is related to the social data. I think that as it is a public deliverable, you should include some conclusion about the Excel sheet on the PDF. Because for the social work, there is a very good description about the work really done, but not conclusions. So what we were discussing before, where to place all the information that can be useful for the different stakeholders, maybe you can shift, if you want, I can write it from 8.6 to 8.2, try to summarize the social results, and well, you can keep 8.6 as it is. The idea is that you try to provide some extra info, because after the WUPI 7 discussion, we can check the tier L for its exploitation, but exploitable result. But I don't know, what do you think, Maria?
Regarding the conclusions regarding the social assessment and the social data, we discussed it when we were preparing the deliverable, and the reason why we put the Excel sheet, it's because it was very difficult to make a conclusion. If you look at the data, it's a methodological, and it's not a result. And that's why we did it like this. Actually, we were arguing quite a lot whether we should put it or just don't put it at all.
Don't put it at all.
Yeah. So I think after your comments, it would be easier to exclude it rather than having some concluding remarks, because you cannot have concluding remarks. It's a methodological approach, and which has to be analytically described.
Okay, and I have a question for Irek. What means that the social approach is related to the kids? What means exactly? Itek? Is Itek? It's not Irek? No?
I can answer probably.
Yeah, probably, because maybe she can answer
better. Okay. The social LCA, social life cycle approaches tend to have a general framework which relates to the building and the use of the building. Now, what we did in this project is we developed facade kits. So we had to adapt this general approach methodology to the kit level. And this is what it is, I think it is meant out of this sentence. And this is why actually we had also this Excel sheet at as an annex.
Okay, I think that...
we have to exclude it.
Yes, and try to explain what,
yes, you are right.
What means the...
You are absolutely right. And I explained to you that we had the same problematic when we were preparing the deliverable. But we thought it is better to include it just for reasons of completion, to make sure that everything is presented. But we can exclude the social aspects.
So, thank you. I'm so sorry that I couldn't comment on that because I was more involved in the LCA, LCC, and the standardization document that we produced, but not the social LCA. Sorry.
But anyway, if you can shift migration from 3.5 to from the confidential deliverable to the public one.
Mhm.
I think that it would be really useful.
Okay.
It's very good. It's very easy to do. You should transfer all the concluding remarks of the LCA from deliverable 8.6, which is confidential, to deliverable 8.2, which is public.
Okay.
And we can exclude the social assessment from deliverable DH2.
Okay. Thank you. So here we can see that we have submitted all the deliverables. Also to remark that 8.6 was not on time, but it was submitted successfully. As we can see here, it was after the resubmission for the acquisition and monitoring data from all the demo sites. We have identified and applied some mitigation measures for these risks. Data required for the LCA and the deduction of the KPIs are not available by manufacturers, and to mitigate this, we employ the use of EPDs for materials or similar components, as it was in the case for the ventilation unit, I think. We have a high operation and production costs, limit PNU application only to niche markets, and we have provided a comprehensive study of business opportunities in task 8.4 that we started in month 25. Another risk, failure to highlight the advantages of the plural concept versus traditional solutions. For this, early communication and dissemination plans were put in place. There was an exploitation strategy that was prepared. The business model defined the exact target groups to help mitigate this issue. And not having enough monitoring data, for this, we was employed an alternative analysis, which is described in 8.6, deliverable 8.6. To summarize the achievements, we have performed LCA, LCC, and social assessments for the 101 configurations of the 3 PNU kits. We have a comparison study from off-site prefabrication versus on-site fabrication. The business risks were evaluated. We have identified the final exploitation plan. The innovation radar was updated and submitted. And to conclude, all the deliverables and the innovation radar have been submitted. LCA, LCC, social assessment for all configurations. We have provided the digital standard for LCA that aims to involve all those scales that we were showing earlier into the regulations, and also analyze which regulations actually exploit that phase or that scale of the project. The plural PNU kits for the certification purposes have been prepared. We have a final exploitation strategy and IPR strategy. The economy benefits of the PNU kits have been estimated to 25 up to 28% in favor of the offsite prefabrication. And the technical, economical, and legal, normative, and other risks were identified and analyzed. Here we can see an overview of the 5 tasks and how they relate to the other work packages. We can see the work package 1, 2, and 7 for the 8.1. Work package 7 as a whole for 8.3. Work package 6 in many tasks for 8.4 and 8.3, and also how 8.5 fed the 8.1 and 8.2 with outputs going to work package 5 and 7 and the 8.4 task on this work package. So this work package has 5 tasks and 9 deliverables. It has been successful with the tasks and deliverables. There was 1 delay, as mentioned, and 8 deliverables out of 9 were submitted on time. Every partner has contributed what they had to for the development of these tasks. And they all showed the progress and results that were expected. Also, 3 exploitation workshops took place to collect data for the exploitable results. Okay, and that's all. Any questions?
Maybe I misunderstood, but I think that the return of investment is not included for Smart Wall. Am I right? I think that you have not included.
We include the return of investment for the Smart Wall in the delivery.
Well, you have included it. Maybe I misunderstood, but I didn't. For
the envelope comfort, for the connect wall, and for Kashava was prepared a case study.
Ah, okay, okay. Page 73. I don't know. Check. Yes. Check, please.
But as Petra explained, we have the return on investment for the 2, and for the third one, we have a case study.
But could you write a sentence there, or in the final report, as you decide?
Because the return of investment as itself is usually done for the real estate purposes when you have a whole building, but we took only the parts. And that's why we came up with some, let's say, substitution for the real improvement of investment. For the 2 plug-in use kits were done more or less the same way or the same way, but for the Kashava it was done with the case study.
This is all explained in the
8.6, which is complete.
Okay, thank you.
The only thing is check again the DLL for everything.
Thank you.
We are supposed to have a coffee break now. If you want to, just for 15 minutes, very fast, because we are already 3/4 of an hour late. So if you just want to go out for pick up a coffee and come back. Are you online? Thank you very much. We are about an hour late. And I wanted to ask you, how do you want to handle this? I don't know if you can wait until, say, 4:30 your time, which will be 5:30 our time, to talk privately with Helena. Or do you want to speak up now?
He was there.
How do you want to do it? The other option is, if you are ready, we can extend the coffee break now, and you can talk the two of you for as long as you want to discuss and arrange whatever you like. Do you prefer later or now? No, that's independent. Okay, I will send. Yes. Which chapter was it? You want to have this also on the top? The 7.6. The Word document.
I took that thing.
Please come back and continue. We have to, the bus has to be here, the bus has to leave the hotel at 5:30, the latest. So the meeting has to be finished by that time. And because the work package 9 is quite an important work package, we have discussed the management issues with Helena so that to skip the work package 10 presentation and devote the rest of the time on the work package 9 presentation. So Anna Tatakova is going to make the presentation.
Yes, thank you, Maria. So I'll be presenting the work package 9. As Maria mentioned, it is also important work package. So the main aim of the work package 9 was to ensure the results and achievements are shared with the right stakeholders in the most efficient way. So to do that, we have defined and annually updated the dissemination and communication plan. We have created a data management plan to ensure mainly the open access, but also the open access to the data and the results. We have raised awareness and promoted the project results to different stakeholders, the manufacturers, different media as well. We have organized and created training activities and cooperated mainly with different cluster projects as well. So here is the Gantt, the overview of Work Package 9. We had 4 tasks. Here you can see the overview and the deliverables we have written and have submitted. So to go over the deliverables now, in the first 7 months of the project, we have submitted 4 deliverables, which is the project website development, the promo materials dissemination communication plan, and the data management plan to set out the plan for the whole project. That way we have reached the milestone number 14. The dissemination strategy was set and the first actions were initiated. At the end of the project, we had 2 deliverables, so the 9.5, which was the awareness campaign report, and also the report on training activities from task 9.3. At the end, we also resubmitted 2 deliverables, so the data management plan and the project website development, since those 2 were updated throughout the project. So we have included those updates in those 2 deliverables. So starting with the task 9.1, dissemination and communication. As I already mentioned, the deliverable dissemination communication plan was set up at the beginning of the project. It is a comprehensive plan that defined the target audiences, different tools and channels that were used to promote the project, and also included KPIs that were set. This dissemination communication plan ensured that all partners and all the open access were set up and followed out throughout the project. So the first task of the Work Package 9 at the beginning of the project was to create a visual identity that would be used till the end of the project, and of course after the project as well. So the project itself is easily recognized among other projects. So we have created a plural logo and also a brand menu, which we followed out. Now moving on to the project website, again established at the beginning of the project. We have regularly updated the project website. The most updates were done in the final period of the project, sharing all the news. We also created e-platform for our training activities. As already we have discussed, we had handbooks that we included on the project website. To easily find them, we also share them on the homepage. It is not included on my screenshot here, but in the meantime, we already implemented it on the homepage, also with the button to the e-platform, so it's fine. It's easier to find it. And also the handbooks are in the e-platform, which I'll be talking about a little bit later, and also in the promo material section. So we have 3 pages where the handbooks and the e-platform is mentioned, so you can finally find it, the stakeholders as well.
Excuse me,
yes.
How long is going to stay the website working?
So the whole website will stay 4 years after the project end. 4 years. So of course, this is not the final look of the website, and as we discussed now, we'll be implementing those public deliverables there and the summary as we already discussed. So this is
because I think that if possible, I don't know, Maria, if possible, it will be interesting to include something about Cassava once it has been completed, to have 3 completed demo, if possible.
Definitely, we have in the training section and also on our demo site pages, we have some information about Cassava. But as we discussed in previous work packages, we also will include the public deliverables, the 8.2, and make a summary of those deliverables, so it's much easier to see on the website as well. So the 9.1 project website that was submitted at the beginning project was resubmitted with those updates, but we'll continue to update the website with more information and the public deliverables and informations. Overall, the project, we have 26,000 views and 5,400 users. So this is what was found out at the end of the project. Moving on to social media, so we have actively been posting and promoting the project via different channels, mostly the LinkedIn platform, but also the Twitter and also the Instagram, where we mainly shared photos from the partners, the demo sites, different events that the partners have participated in, and also a YouTube channel was created. We shared different milestones, and I'm happy to share that we have reached 623 followers, and also we had 110,000 impressions overall. Moving on to the promo materials, so during the project we have created brochures, which the brochure was the latest updated promo material, which you can all find on your tables that we have created and updated. Different roll-ups, leaflets, posters, but not only these promo materials, but also different merchandise like pens, posters, different presentations for different events to reach the right audience, to reach the right stakeholders, and to promote the project as much as possible. So here you can see all the promo materials that were used during those projects. As I mentioned, not only the paper ones, but also pens and different posters. Now moving on to the videos. So during the project we have released 15 videos, mostly focusing on the training, also the demo sites, but explaining as well the project to the public. So a graphical video with explanation of the solutions of Plural. Also the training videos, modest license platforms, and different workshops as well. Overall, we have reached 1,100 views, and of course these numbers are growing as we speak, as we have all included on the website and also on the e-platform as well. Newsletters, we have released 6 newsletters during the project to different stakeholders that have subscribed to our website. Very happy to share the number. We have over 1,000 subscribers and downloads of the newsletters. Also, thanks to our clustering, different sister projects and clustering projects, we were able to reach even more wider audience and different stakeholders. The project partners and the consortium has participated in 45 events during the project, including different workshop fairs, conferences, webinars as well during the COVID-19 period, which they were promoting the project, the results and achievements, and also made different presentations, used the materials that we have created. One of the key events I want to highlight is the Sustainable Places Conference, where we participated for 4 years. We also organized and co-organized different workshops there. I'll be talking about those a little bit later in clustering, where we cooperated with different projects as well. Not only we have participated in projects, as I mentioned, we have also organized training activities and workshops where we have engaged with over 200 participants. We have also shared our results in different articles, magazines, also conference proceedings, and thematic portals like EU Build Up, where we mostly shared press releases. At the end of the project, we had 63 press releases sharing different news, the participation of our consortium and different events, and also the updates of the website. And now moving on to the, yes?
Sorry, that is not for you, it's for everybody.
Ah, okay.
This is the last period for the project, and you have only 3 articles, and you have a lot of results. And I suppose that you are trying to use the results. Then for me, it has been a bit surprising that in this period that you have a lot of pieces that you can sell to other people, you have so little results in publications. Well, try to do something more about, because it's useful for you.
Okay, thank you. I will address a little bit the comment a little bit later in my presentation. So I will just go on regarding the sharing of the results. So first, I want to also highlight, speaking of the publications, the joint publications we did with other clustering projects. So we have joint articles as well with the different... Yes. So we have a team up with 7 different projects where we regularly met on monthly basis to discuss the progress of each project and also discuss the synergies between those projects. We have a dedicated section on the website to highlight all the collaboration and cooperation efforts of our project. So here is the list of the joint publications, different publications we have shared. We are also featured in newsletters, and also our results featured in different projects' newsletters. We also authored a positioning paper and published 2 joint articles as well. Here is the list of our clustering events. So as I said, we have also participated in different webinars, and mostly at the Sustainable Places Conference, which we have been participating in throughout 4 years. Some years even we have cooperated or co-organized and ourselves organized different workshops. The Sustainable Places Conference was a great event to share all our results as well. Not just with clustering project, but also with the audience. And then we have other workshops and events we have participated in with those of clustering or sister projects. So moving on to cooperation, here I just want to highlight the 2 publications, which are 2 technical articles which we've written for the EU Build-Up portal. So the plug-and use renovation and adaptable lightweight systems, and the optimal parameters estimation in NZEP renovation projects. So these are the 2 technical articles we have written. Also, we have participated in the expert talks on the Build-Up portal and had quite a close cooperation with them, releasing the press releases and featuring the project also in the ECTP portal as well. Now I'll move on to the task 9.2, which is the data management plan that was developed in early of the project, but was also annually updated and resubmitted in M36 that followed the progress and the data collection of the project. And also the data management plan was implemented throughout the whole project and work packages, but mainly into dissemination, communication, and exploitation strategies. The task 9.3, so the training activities. Here I just wrote a summary of all the activities we have performed mainly in the last period of the project. So we have created an e-platform where all the activities, the workshops, different tests can be found. This is on our project website. Also on the homepage, there's a button, so quite easily to find, with also the handbooks included there that we already talked about. There are some recording session about the Modest and SME platforms, and this training course and the website itself will be live and active for 4 years after the end of the project. We have equipped around 150 participants with practical skills, and also already 300, we had 300 visits to the e-platform. Here are the many times mentioned handbooks that we talked about, so I'm gonna repeat again, just to mention they're on the homepage, on the platform itself, and also in the promo materials section, so people can download them there as well.
So who is responsible for each handbook? Because maybe I didn't read properly. LCA and LCC is e-tech, industrialization best practices.
Yeah, it was collaborated effort by many Phoenix and AMS. Yes.
This one, I think that could be completed with this summary that we are trying to compile here. And the third one, the certification of innovative solutions, is e-tech.
E-tech.
What we talked about.
Okay. Okay.
Yes, so this was collaborated effort by most of our partners, and then it was created, the content by Phoenix as well. This was to support the training activities, and we can even more summarize the content of the handbooks on the website to even more have some content. And moving on to the last task, which is the advisory board, which is a group of experts from different and diverse fields, and includes specialists from industry, academia, and administration. They supported the project with insight and on policies, innovations, and user needs, and also provided feedback during our meetings as well, and of course contributed with their expertise from their field. So just to mention the achievements overall, the Work Package 9, it was to increase the project visibility throughout the different channels and tools we have used, facilitate effective sharing of the results and lesson learned, creating the e-platform, engage the stakeholders, and we have created very strong relationship with the different clustering and cooperation projects and portals as well. Then training initiatives ensured that the professionals were equipped to promote, after the end of the project, the plug and use systems as well. And also we have ensured that the open access policies were implemented and the data management was managed properly. So here are the conclusions of Work Package 5. So we have delivered the strategy ensuring the dissemination communication, ensured secure, open, and structured data management plan, and equipped the professional with the skills for the implementation of player technologies, and provided valuable external expertise from the advisory board to enhance the strategies to use further as well. So this is all. Any questions?
Not really. Thank you very much.
Okay. Thank you. That's all for me.
to the tier L. If you can help me to decide the tier L for its exploitable result. The envelopes, I have tier L9, and in 1 year, less than 1 year, we are expecting to put into market. It's like this? Yes, okay. A smart wall, tier L, the whole system, tier L8, could we change to 1 to 3 years?
Yes.
Yes?
I have already spoken that with Digitech because they were providing the panels for Bula, and yes, we can do it.
Okay. Okay. Connect wall, tier L7, and 1 to 3 years is okay for you?
Well, I think in 1 year it's going to be, it could be tier 8. Now it's tier 7.
No, tier 7, okay.
So what do we write? 1 to 3 years?
1 to 3 years, okay. The air handling unit, here we have 7 and 1 year. One of the two things has to change.
I think in 1 year it could be also tier 8.
Okay, then, and when would you jump to 9? Because if we are 7 and we can't keep 1 year, to jump to 9, then what do you prefer? 1 to 3 years? The window is an improvement. Then now it's 7 and 1 3 year. So, what do we keep? Okay.
8, 3 years.
2 years. The smart control for a smart wall. 2 years. Nano coatings. 1 year. Okay. 3D printing. 1 year. Lysis. 8, less than 1 year. Is okay? Yes. Okay. The SIM based on MPC, 8, 1 to 3 years, IREC. Is okay like this? Yeah. Okay. Indoor air quality tools, 7, less than 1 year. This is
CBUT. It's your the indoor air quality monitoring system.
Well, it's 9 already.
It's already 9.
Yeah. Okay.
Commercially available.
And finally, modest, 6, 1 3 year. 7. Okay.
Where should we connect this in the innovation reduction? Is it me or is it-
Θα το κάνουμε.
So thanks, everybody. It has been a really long day, but for me, really fruitful. Well, I'm happy to be reviewing this project from the very beginning. I learned a lot. Thanks, everybody. I think that after all our discussion today, I'm trying to go by work package. Work package 1, everything is okay. There is nothing to change. In work package 6, I was proposing that you provide a kind of summary about cutting-edge technologies. But in order to keep this deliverable as it is, we can translate this table to deliverable 7.6 that is related to technical feasibility. Then we keep deliverable 6 as it is. In work package 7, here what I propose is reopen this deliverable 7.c. I will be happy if you can include some comments about the assessment from technicians for the 3 demos. In this deliverable, that is a public deliverable, also I will be happy if you can provide a summary for each chapter. One for the comparison between demos, one for the monitoring, one for the KPIs, and I don't know, I think that there is one other big chapter, demo monitoring, KPIs, and LC, but this we can put in work package 8. For work package 8, we are going to reopen 8.2 and 8.6 in order to shift the public contents from 8.6 to 8.2. Here, it will be the right place to update the tier L for each exploitation result. You have a table you can put there. And I think that's all, to try to update the public deliverable and to provide, as for deliverable 7.6, to provide summaries for each chapter, because these 2 deliverables are to be read by others that are not involved in the project, and then I think that is your best way to jump to market. And for work package 9, 8.6 is confidential. Then you can shift chapter 3.5 to 8.2 and to complete 8.2. And for work package 9, well, I keep my recommendation about try to use your own social media, your own channels in order to emphasize the good work you have developed. I think that you have worked hard and you have obtained very good results. Then try to sell these results, because finally the idea is that you are going to continue with all this research and activities. From my side, nothing more.
Thank you very much, Helena. Your recommendations and observations are very valuable and productive. I think we will try to implement them as soon as possible. During the coffee break, Helena had the private conversation with our project officer, and the next steps are Elena is going to communicate with the project officer regarding the changes that have been just discussed. The 3 deliverables will be rejected and reopened in the participant portal, and we will have the month of December to do all the changes and updates and complete also the financial statements and the financial report, the technical report. This doesn't mean that the financial statements can be submitted on the 31st of December. The financial statements have to be submitted yesterday so that we can do the analysis and include the modifications and justifications in the technical report. Here comes the bad news that I just heard from the project officer. The Commission services, due to Christmas holidays, are out, not functional, practically after the 15th of December, as far as I know, and this may go on until the end of January. So when we submit everything, we should not expect to have the final feedback from the Commission before March.
Well, I will try to do my work as quick as possible, but the steps are you have to send the financial and the deliverables. I have to submit my assessment. Then the project officer has to, and the financial officer, that this part is also quite complicated. Then, well, if all of us, we try to do as quick as possible, I think that you will be paid sooner.
Well, I don't mean to be realistic and not expect before March. Normally the procedure is after Helena submits her extended review report, the Commission sends it to me together with the financial report, or sometimes independently. We have to respond to both the technical final report and the financial report. In case we have rejection of the financial statement of one or more partners, we have to do the changes and implement them. And then we have to wait until the final approval by the Commission. All this may take 2 to 3 months. So we should not expect to receive, if everything goes well and everything is approved, the funding, the remaining 15% before March. But this assumes that we keep this time plan as we discussed, that from our side we complete everything within December, and then we work in parallel with Helena to speed up the procedure, because if Helena waits for our final deliverables and then she starts, it will be June before we finish everything. So Helena has been very nice to be cooperative and try to speed up everything.
But my experience is 3 months.
Yeah. It's so.
Well, I did my comments. If you want to say something now.
From the partners, if you want to say something. I would like to just to add something that it was not mentioned in the presentations. As a result of this project, we have already some bilateral collaborations of partners after the end of this project. And as a consortium, we would like to have the opportunity to continue. And we are trying to find ways of doing this. It's not up to you, I know, you cannot help on this, but this shows that this consortium has been on a good track regarding collaboration and developments, and we would really like to have the chance to continue working together. The last year of the project has been very, very intensive for all the partners, and probably this was one of the reasons why we didn't have the scientific publications. I know that the research partners are always interested in having scientific publications, and this can be done after the end of the project, obviously acknowledging the funding of the project. And we already have publications that are scientific publications, collaborative among the different partners.
For all of you that are applying for funding for small pieces that you already have, keep in mind the Eurostar program, that is a program for SMEs that is not complicated to prepare a proposal, and usually they have money. They have always remaining money. Then if you think about pieces or nano coating or the smart control or such kind of things, so, well, try Eurostar because they have 2 opportunities each year. Then if you need to be funded, try it.
So I suppose it's time to close.
Yes.
I would like to thank all of you once more for the commitment, the dedication to the scope of the project, for being optimistic and collaborative to overcome all the problems. I remember my explosion in Terrassa, which was disastrous. That shows how intensive the last year of the project has been. I thank each of you personally for trusting me and for overcoming all the problems that we had during those 4 years. I hope we will have the chance to work together again. And I would like also to thank Helena once more for the productive comments and having a very practical approach in assessing the project. So I think now it's time to, well, we have half an hour before the bus comes, but in the evening we can have a glass of wine to officially celebrate the end of the project. Tomorrow we will visit the Vula demo site, and in the afternoon we will have the open event where the manufacturers will present their technologies for the open public. Phoenix will present the training activities, and I will make an overview of the industrialization procedures. This is the program from tomorrow, and then from there on, for those that stay here, they will have a rainy weekend in Athens. So thank you very much.